Good morning.
So I think now all these nodal centers are connected and you have your participants there. So we are going to start the course shortly. So now we have moved on to the third day. So we have with us Dr. Satveer Singh. He has more than 15 years of experience in teaching and is presently Associate Professor and Head, Department of Electronics and Communication Engineering at Shahid Bhagat Singh State Technical Campus, Firozpur. His field of special interests include evolutionary algorithms, high performance computing, type 1, type 2 fuzzy logic systems, wireless sensor networks, and artificial neural network for solving engineering problems. He has published nearly 50 research papers in international journals and conferences. He has delivered nearly 25 invited talks during national and international conferences, seminars, short-term courses, and workshops. He completed 2 AICT funded projects under MODROB scheme worth 15 lakhs. At present, 8 PhD scholars are working under him. With this long list, like this was a short thing which I took. He has his own website also. So when I went and saw there, it was a very long list. So I just scripts, I made it crisp. And you can also go and see his website. And he has done a lot of work in this field of optimization. And I think he's the right person here to deliver a lecture for you. And all the nodal centers also, I think from the first day, many of them, they were asking me, ma'am, is that optimization there? And can you have a longer session? So that's why I gave him one more session and I made it a little long. So I think you will make best use of it. And I now just welcome sir here and I hand over the session to sir.
Thank you, Simi.
सर आप देख सकते हैं ये जो ट्रांसमिट हो रहा है ना इन केस आपको आपका इनको आपकी मैटलैब का विंडो दिखा रहा है और यहाँ आप आ रहे तो स्लाइटली सिग्नल दिखा दिया तो चेंज कर देगा बट अदरवाइज दे आल्सो नो वो अपने आप चेंज कर ये उनको ट्रांसमिट हो रहा है
Hello. Hello.
Hello, sir. Hello, yes, sir.
Hello.
Hello, yes, sir. Any problem, sir?
Have any problem? You can't get connected?
I view his cultural, educational, political background. So, and then.
Initiating with the topic. Topic is all MATLAB. We are supposed to talk about optimization and important for us that whether we are going to program or we want to use some kind of toolbox that is available in the MATLAB. That is also a way to solve your problems.
Hello.
Any person who is having
Hello.
computer programming in MATLAB. MATLAB. I'll take up some algorithmic view how we handle that optimization problems. Before that, I'll float another small scenario. Okay, if I want to say that I want to solve one real life problem, how many parameters will be there in that problem? Real life problem and how many problem parameters will be there? Any problem you can just say it out. Yeah, number is quite large. Normally we talk about. Let us say if I want to come from Firozpur to Chandigarh, how many maximum number of path can be there? It's very large number. You know? In between, I can go one from that street or this street or another road. Many other cities are also there in between. but I choose one. And there is some reason for that, although that is what being done spontaneously by me or my driver. It's not an issue for us to think about that, how many possibilities are there and how to go for that. But it is actually the artificial intelligence that makes us to think like this, and we solve our problems, daily routine problems. Another problem may be something like, okay, how many parameters are involved in simple cycling? I want to go for one place to another place. How many parameters are there? Those control my cycling process. 5, 6. I have to take care. No, let us start talking about. I'll have to take care of the road condition. I'll have to take care of the center of gravity. Distance I have to go. Direction, obviously, that's a part of that. And in addition to that, the paddling speed, how it is to be. Steering, how it is to be controlled. And if brakes are required, then when to apply brakes. There are many parameters, I think. And if we want to make some kind of formula, is that possible that we can do it? Can we make some kind of formula that can be given to the computer that please, this is the formula and do cycling for me? I think it will be very difficult for us. I don't know, we people are doing this without thinking much about that even. We normally talk about something else, but we don't take about. Even similar thing is with the driving also. We keep on talking to our adjacent co-passenger, those are sitting with us, and we never bother about brake lagani hai to automatically पैर दबा देगा. So that's the. There are many other. This is what is the realistic real life problems. Once we are talking of the engineering problems, these are simplified problems. You know, we have, I think most of us might be knowing something about BJTs. We first say that temperature is not going to change. Why? Why it is not going to change? Why beta cannot change in between? Because it will affect the working of that transistor or the amplifier that we have in our under consideration where we people are working on. We freeze many parameters or ignore some parameters, those are not contributing much to the problem. And then this is how we reduce the number of parameters. Then with the reduced number of parameters, we make some assumptions that, okay, transistor is not a linear device, but it will behave linear within this region. Further simplification of that problem so that I can apply Ohm's law. Otherwise, I don't have the formulas to handle non-linear devices. Then we make H model or pi model, then we think about that. Okay, then this is what is the way, how do we handle engineering problems. But if I say that, no, I have to solve problem, whatever the realistic real life problems or the constraints are there have to be taken care of. Then it becomes very difficult. The parameter number becomes very large. Okay, another feature, whatever we refer to, say the traditional mathematics that we use to handle this kind of problem can support only 3-4 parameters. I think we have undergone the course of partial differential equations to handle multiple parameters. We make one silent and speak another. What is the difference? Then we aggregate them. Then we get it. Something like superposition wala concept, and it's the same thing is applied there. Then we can handle some parameter, but still differential equation of the order of more than 3 or 4, then it will be a problem. Will not be able to handle. Parameter number can increase. That we have already talked about. Then how to handle that kind of problems? Because presently, if we say that computer can do all calculation for you, but it has to be taught what method has to be followed. This is what is the bottleneck problem. There we have to, okay, we can solve to some extent. There are many mathematics people, those are working in handling this kind of problem. They are taking it as a research issue. Okay, I'll be able to handle that. with some or the other mechanism, maybe taking more time, maybe having requirement of more computational power, I'll be able to handle that problem. But is that my objective? My objective to have an approximate solution. I'm not required to have very precise solution. Isn't so? Okay, to appreciate this concept, let us say that I came from Firozpur to Chandigarh. How much time it should be taking? 4 or 5 hours. Is there any person who is going to say that 4 hours, 30 minutes, and 25 seconds? Isn't so? We are always requiring approximate answer to our problems. We don't want it to be very precise. It's all useless. We do not interpret numbers, but definitely to some extent it conveys the idea that this is the approximate number and you can make some decision. Okay, if I talk about that, how is the personality of this person? Okay, if I take one parameter of a personality, dressing कैसी है? Okay, I'll talk about this is how the dressing is. You'll say, okay, it's good. Okay, I'll say that, ठीक है, I'll understand what this good means. That is what the concept of fuzzy logic. और जब हम कभी आज ठंड है थोड़ी, अगर मैं लेट अस से कि रास्ते में कहीं रुक करके चाय पीना चाहूँ, तो मैं उसको क्या बोलूँगा? गरम गरम चाय दे दो. Isn't so? I won't say 80 degrees Celsius. Or I need a tea of maybe 150 grams of milliliters. We don't talk about that type of numbers all the time. We say 1 cup and garam garam. That we understand, and we make decisions also that this is okay, this is not okay. But ठंडी हो गई है चाय. That is the linguistic way. How do we handle our real life scenarios? And we want the computers to do that for us. I should be reaching my destination. I'll be solving my problem, but not with very precise solution. It's not that demand. That's why the concept of approximate computing or the soft computing techniques came into existence. Okay, I think this is something that is very much important. Now we'll be talking about the algorithms. Those can give me solutions, or those can help me in identifying the solutions from thousands of solutions. Thousands or maybe sometimes lakhs of solutions I'll be having, and I'll be able to identify that this solution is very suitable for me. Okay, so this is what the demand of us also, that time is limited, that I have 1 day and my problem is to be solved. I have a solution of let us say total in number 1 lakh. One solution can be evaluated in, let's say, 1 hour. Then how many hours I will be requiring? 1 lakh, approximately 1 lakh hours I will be requiring. But my objective is to identify one solution within a day. Now how it can be done? Okay, so that is the task of this optimization. We'll be optimizing the solutions, or we'll be having rather from 1 lakh solution, I'll be picking up say 10 or 20 solutions randomly, and then mixing them in such a way that they'll evolve as a one best solution. They'll evolve themselves as a one best solution. This is why it is sometimes called as a swarm intelligence, because we are having a swarm of solutions. It's a crowd, it's a group of solutions. Those work collectively to give me some solution, and that's what is the modern, we call sometimes, heuristics that we take into the programming part. Heuristics is something, the common sense or the natural concepts that we see in our nature. How do we behave, our system, our social system features, we try to copy them into computer programming. That's why computer programming is separate. That's why I talked about that. If you are comfortable with computer MATLAB programming, then I'll be talking about the logics. Then how the logic works, then you can code it into the form of some computer program and solve your problem of your domain. I'll be talking generic things. Okay. This is the basics of the need of heuristics. Why we need heuristics to be taken care of for solving our problems. Genetic algorithm is one of the very popular and still I'll say it is having some features those are not available in many other optimization algorithms, although there are more than I think 15 or 20 optimization algorithms available in the market, and we are also working on one of the algorithm, and results are good, but my objective is not to talk about that, but there are many objectives optimization functions or the optimization algorithms, those can be used. Genetic algorithm is one that has some features those are not available in other optimization algorithms. I'll talk about that sometime. Then particle swarm optimization, another very popular optimization algorithm. I'll take up some examples with this. It's having now you can say whatever the particle swarm optimization algorithm or the technique has some inbuilt qualities are being copied in most of the optimization algorithms. That's why I have taken over here. And then I'll try to show with some MATLAB demonstration that how they are actually working. Maybe if time permits, I'll try to show you the code also. Otherwise, this code is available on the website that I have. It's drsatvi.in. Okay, you can download it from there. The Firefly algorithm, we are working in modification of that, and I'll talk about something that this algorithm is giving a bit comparatively better results. Or because once we people are into research, we want to show our results in a better way, and we want to have. Definitely, in all these algorithms, you'll have to tune your parameters. Strategy parameters has to be tuned first. Then only you'll be getting your results. It doesn't mean that every algorithm works equivalently good in all the application. Depends upon your parameter tuning. If you tune your parameter in such a way that suits your application, you will be getting better results with the one algorithm may not be suitably available from the other algorithm. You'll have to take care of that. Once you check one algorithm for your application, and you'll have to be very carefully decide the strategy parameters also. That we'll talk about. Real life problems we have talked about is highly complex. जैसे एक मैं अपने स्टूडेंट्स को और एग्जांपल देता हूँ कि भाई मैंने आज एक कटोरी दलिया खाया है एंड आज मैं कितना टाइम बोल सकूंगा कैन वी हैव सम काइंड ऑफ फॉर्मूला फॉर दैट इट्स अ हाईली कॉम्प्लेक्स मैकेनिज्म आई डोंट नो वो कहाँ गया एंड वो कितनी एनर्जी प्रोड्यूस करेगा एंड इट्स नॉट पॉसिबल दैट आई कैन मेक सम काइंड ऑफ फॉर्मूला हाउ लॉन्ग आई कैन टॉक नाउ and this is not possible to make some formula. It's highly complex. It's highly non-linear also. Large number of parameters are involved, and a bigger thing is that I cannot express in the form of mathematics. If even I have parameters also, it cannot be. So that I can write a program. भाई आज आपने इतना खाया तो आज तो ये तो लेबर वाला बहुत बढ़िया तरीके से यूज करता नहीं तो इसको. Okay, so this is what is the nature of the real life problems. Okay, then engineering problems are simplified. I talked about if I want to design some kind of amplifier, I'll have to take care of that. BJT is not a linear system, but it can behave a linear device within some constraints. Once you make some kind of biasing, you make temperature constant, you make beta the current gain of a transistor constant for some time, then you can make some approximate calculation. Whatever the calculation at the end of the all that process, you will be getting an approximate gain of the amplifier. That this is the gain that should be getting. Okay, this is the simplified way that is very popular among electronics people. That's why I've just raised that. Okay, there are some nowadays some softwares available in the market. Those are based on empirical formulas. Empirical formula, we have some formula, but we don't have derivation for that. But it is working. VLSI design and ORCAD and some other computer design tools are using these empirical formulas. Those are giving us practical results. They are taking care of all the parameters, but there is no derivation for that. That is the issue. Because in engineering we say that whatever problem can be solved using mathematics is only engineering problem sometimes. But now it is not the scenario. You can have mathematics without its background support, but it should be solvable. It should give you results. If it is working, then it's okay. Whatever the things that we have, we humans have, we want that it should be available with the computer also. For example, large knowledge base. We are having small brain, but a lot of knowledge is there, and it keeps on accumulating and keeps on refining also. And that's what is actually containing all the things, that how the things happen in the world. I know that this phone can ring anytime. I have that idea, and if it is done like this, then what to do? Now, how to behave in that case? How do we communicate with among people? And even now, some people are interested in talking to or training to the animals also. That's what is possible from the knowledge network, knowledge that we have. We have ability to adapt to in the perspective where we are now interacting with. Let us say if I say that the temperature is about 1500 degrees Celsius, so it cannot be a temperature of a body. It can be a temperature of a furnace. We know that. We can interpret that किसके बारे में हम बात कर रहे हैं. So this is what is the things that we humans have. We want it should be available with the computers. Okay, they should be able to perceive, recognize, understand with the real world problems. They should be able to give reasoning. That's another issue. We are given a scenario. From that scenario, we should be able to extract some knowledge, and based on that knowledge, we can have some crystalline form of knowledge that can be used for handling some other problems. Okay, that's what the human can do, but at present it's not possible with the computer. But artificial intelligence people they're working on this scenario that we want to make robots so those can behave like humans. Okay, so that's the requirement that we want. Okay, how these objectives can be achieved? The issue that we want that computer should be able to do this for us. What are the tools? What are the techniques? That's the soft computing. Soft computing is one. Many people may say it is artificial intelligence, soft computing, approximate computing, may some other terminology you can talk about. Lekin, if I say that these are the three main pillars of, you can say, the artificial intelligence. It's fuzzy logic, how humans interact with each other and interpret knowledge. They can handle uncertainty in the variables, and even then we can make decisions. We do it unknowingly. I know that whenever we face some kind of interview, I know I may ask some question during Viva exam. I'm asked or I'll ask some question. Based on the answer, I'll be trying to interpret how much the knowledge the person is having. Then we make numbers also. In case of interview, we choose or we not choose. If this person is suitable for my institution or my organization or not, that is only based upon the answer that you give. And various type of questions are asked depending upon the scenario. Some kind technical questions are asked, sometimes HR questions are asked, personality related questions are, stability related questions, that person will be stable or not. We try to extract knowledge from these question answers. Then we interpret into some kind of decision making. Okay, this is what is the concept of fuzzy logic. I'll not go into much detail of that. I think there will be some special lecture on that topic, how the fuzzy logic is. Then neural networks, humans have small brain, but it is, if you go into that, there are about 100 billion neurons in a brain, and every neuron is connected to almost 1,000 other neurons. The network is quite large. 100 billion, 1,000 connection of one, about 10 raised to power 15 neuron connections are there. And although we try to make into the computer terminology, computer processors are being into the, research. The people are working on creating some kind of artificial brain, but it is still in research. We want to have that type of, and this is a network that trains, that requires some training mechanism. Then you can use it. Once we people were like kids, so we were not able to walk. Then we learned that. After that, our body adapts to that. We don't learn again and again how to walk. Daily morning, we do not do it again. That morning में सवेरे उठे और फिर चलना सीखना शुरू करेंगे फिर दोपहर तक. So it's done only one time and it is then in use. So that's a very good paradigm, that if we can make computers to learn in such a way how humans are doing, then it's going to be a big contribution towards getting intelligent systems. Okay, then the evolutionary algorithm, that the thing, the optimization algorithm I'm supposed to talk about. This is also once that nature is established itself, and now it is very robust. We human people have behavior that evolve daily. अगर मेरे को कोई कहता नहीं आज कुछ ऊंची आवाज में कुछ बोलेगा तो मैं उससे बात करते समय अगली बार सोचूंगा, ध्यान रखूंगा कि हाउ टू टॉक टू दिस पर्सन, इसका टेम्परामेंट कैसा है ना. We learn that, then we use it, and we learn it from social learning also. We have some learning is spontaneous within the system, in my own system, some learning from my parents also. That's a genetic learning. Whatever the features of my parents are there, if they were very intelligent, then some feature may be coming into me also. And this is what is the genetic improvement in the learning. The another is my society. Let us say if there is a class of 50 students, then one student can learn from another student also. One student is performing very good, is giving 6 hours daily for studies and 1 hour for playing games and 1 hour for just other things and friend circle, and this is how he has planned his, let us say, daily routine activities. Another student can learn a similar way. I'll take another small example. During my BTech studies, I have been passed from a government school, but once I go into college, there were people, those are from having very good background, their style of studies were very different. Once I interacted with them, then I came to know this is another way that can be followed for studies, and I tried to adapt that. Then obviously improvements was visible. This is called social learning. We learn from each other. If you, let us say, in a crowd, you forget your path, where you are, where you should go. Let us say in a city, you get lost somehow. The easier method is to follow that path where most of the people are going. And they'll be definitely going towards some kind of main highway sort of, and you can get out of that problem. This is a social learning. If you feel sometimes, this is the way how you can. Okay, then there are many other algorithms. Birds also have their, ants also have some mechanism. They remain in a group. Honeybees also remain in groups. So these are some algorithms developed from these concepts. I'll just give some names of that. Then I'll come to the problem of genetic algorithm, that how the algorithm actually works. Genetic algorithm, the whatever the features of parents are there, these are copied into the kids, and this is how the optimization may occur. You know that our parents were having one lifestyle, we are having some lifestyle, and we can expect that our kids will have even better lifestyle than us. Whatever their features are there, they are better than us. We had the features; those are better than our parents, and we are improving genetically also. This is the concept is to be mimicked in the form of algorithm to solve our engineering problems. Okay. Biogeography based optimization. We know that birds fly in a flock, and they also migrate from one place to another. Where we are copying the concept of bird flock, it's called particle swarm optimization, where we consider their migration from one place to another place. That's called biogeography based optimization. These are two different learning mechanisms, you can say. Those are copied into optimization problems. Bacteria is also very intelligent. Otherwise, bacteria is not suitable for us. We always take antibiotics, but their intelligence is something that they change their path. Once they see some kind, they sense. They are having also sensing mechanism. Once they sense the antibacterial medicine is injected into the body, they change their path. In such a way, they can get away from the antibiotics as long as possible. That's why it is said that अगर आपने antibiotics ले रहे हैं, take full course of that. Otherwise, it will become more rigorous, and you'll be in big trouble. So that is the thing that has happened with that. यहाँ पे हम लोग इसको दूसरे तरीके से सोचेंगे. We'll be talking that they have some intelligence. Their intelligence is to be mimicked algorithmically to solve our engineering problems. That is the way. Okay. Then mimetic algorithm, genetic plus PSO. Once we combine them together, we call it mimetic algorithm. Some genetical learning, some social learning. Just like human people, we always don't have all the features from our parents. Also, we have some learning from our friend circles, some neighborhoods. Then we are supposed to be one person who can survive in the world, and that is the overall mimetic algorithm. Artificial bee colony, another paradigm. This is something like how honeybees are working. Once they are in a group, we cannot dare to touch them, but they have some features. Those can be copied in optimization algorithm. Cuckoo search is another one algorithm. There are about 17, 18 algorithms available till date. But now I think the number may increase. Now the question is coming up, why you are giving another algorithm? That is also how it is better than others, whether it is applicable to every application or not, whether it is giving best result in all the application types of applications. That is what is the demand now. Okay. Then artificial immune system, how our system, you know, once we are getting attacked from some kind of virus or bacteria, our body starts heating itself. Can we have a system like this that कि भाई मेरे कंप्यूटर के ऊपर अगर कोई अटैक वायरस का हो रहा है तो वो भी अपने आप को स्पॉन्टेनियसली रिएक्ट करे कि भाई नहीं मेरे को इसको खत्म करना है या इट शुड नॉट सर्वाइव. तो मैं अगर ऐसा कॉन्सेप्ट अगर सर्वर के ऊपर लगा लूँ, आई थिंक नेटवर्क के ऊपर लगा लूँ, आई थिंक वी कैन हैव बेटर सिस्टम. Okay, that is another way of optimizing the system. Firefly and glowworm swarm optimization. These are two different algorithms inspired from one insect. You know, जुगनू जिसको हम बोलते हैं. So it is inspired. One insect inspired two different scientists at the same time, but different mathematical background. Now it is. It was reported, I think, in the same journal also. But two different scientists have done this thing. One was Indian from IIC Bangalore. The another person was from US. So they evolved with the same idea that how these fireflies interact with each other. Can we use it for optimization? And they are given very good results. That's why I have taken into this discussion also that their performance is quite good. Even we have identified some scope that it is still possible that you can improve, make some kind of improvements. Wound healing, this was the one algorithm that we started working on, but not succeeded much. But it is one, you know, that whenever we get some kind of wound on our body, it automatically, you know, repair itself. How it happens, how human system is designed to be. Can we learn something from that? I accept that I could not model it that good. That could be, I think, and even maybe you can take it as your research area. Yeah. Uh, Otherwise, if you say that how to check that whether they are applicable to optimization area or not, there are some set of benchmark functions. Whenever you design some optimization function, it has to be tested on these benchmark functions. Once they perform there, then you can apply on your domain area. Okay. All these algorithms were tested on a benchmark function. There are about 30, maximum 30 optimization mathematical functions are there, and every test results have been presented. Whichever is performing better on all these test functions are supposed to be better as compared to others, and then only we choose that. Okay, my problem is like this, and this is suitable to this. This seems to be similar to one or two optimization function. Then you can choose that this algorithm is suitable to my application. Okay, I'll give some idea कि वो function दिखते कैसे हैं. I have lots of some functions, not all, but few function will give you an idea that how they look to be.
Want to develop our own algorithm. Say, I am inspired by something.
Uh-huh.
Is it like I have to develop a mathematical modeling of that? Because that is the first thing. Or we have to go and study that biologically. If it is GA also, what was the base? How did they find? Like we don't know about the body composition and all those things. So we have to go study that, like how the chromosomes and all those things are working. And then should we develop the mathematical modeling for that?
Okay, I think you have some idea about genetic algorithm. There is string, and we know that strings get twisted to some at some places, and how it is to be done. If it is possible to be done with the mathematics, then do it with mathematics. Okay, if it is not possible with mathematics, it is possible to be done in a form of algorithm, then do it with the algorithm. Mathematics is a supportive. You are actually mimicking some biological process. Okay, whether you do it mathematically or you do it with pseudocode, then it's not a problem. It's not an issue. But you can have one-to-one relation with the biological and artificial model. Artificial model can be anything. Maybe mathematics, maybe non-mathematics. First, mathematics is supposed to be better because computers are meant for that calculation purpose. Otherwise, algorithms are also possible, but it takes some time. It is process. lakhs of papers have been published on fuzzy logic. Type 2 fuzzy logic, it's a bit new, but not that new. Even about 20,000 have been published. This is the data given 2014. Neural networks, evolutionary algorithms, genetic algorithm, particle swarm optimization. These are some keywords searched on Google Scholar. Then I can see that how many papers are there. Okay, let us start with the genetic algorithm. Okay, before starting with the genetic algorithm, what do you feel about these kids? क्या इन सबके पेरेंट्स एक ही होंगे? Yeah, that is the genetic algorithm. That's it. अगर आपने ये चीज को समझ लेते हो तो you can appreciate the concept of genetic algorithm. Okay. Otherwise it is based on the survival of the fittest. अगर हम अभी तो ह्यूमन के ऊपर का इतना एप्लीकेबल नहीं है, लेकिन अगर मैं कहें कि भी नेचर इज समथिंग लाइक दिस कि the concept is survival of the fittest, Darwinian theory. There are some processes into this genetic algorithm. Those are actually mimicking natural system. Selection of parents, one, where we choose parents to create next generation. And then next process is crossover. They produce next generation and their genes get mixed. You know, अगर किसी के मतलब फादर की या मदर की आईज का कलर ब्राउन है या कुछ और है, तो मोस्ट लाइकली इट इज टू बी कैरिड टू द किड्स आल्सो. This is one example of gene forwarding to the next generation. Okay, then this crossover, here I'll be talking of single point crossover. It may be multi-point crossover. There is some variant also. That there are many features. Is there any query? Okay. There are many features. We are still in the process of decoding of human gene, or how they can be, they'll be contributing towards the new generations. So this is what is the just an idea that we will be making this logic also. Okay. Then some features are there into the kid, those are their own. It's not from even parents. What is the break time? Okay. Okay, there are some features in the kids, those are not coming from their parents. That is also possible. This is the process, is called mutation. We'll be doing the same thing in algorithm form also. Okay, and this is just a flow. How, if we talk about the computer, how computer can work, it is to have some kind of flow. Okay, first we'll start with creating a random population. Random chromosomes will be there. I'll be having system parameter encoded in the form of a string. String is something the parameter. Okay, let's take some real life problem. Okay, I'll take this one. This is one pen. What should be the length of this so that it should be comfortably? What should be the width of this? How much ink is to be poured into this so that it can last at least for 1 month, or it will require one clip also, or some other color for attracting the envelope. Okay, so these are some parameters. Those are going to be a design parameter of this pen. Okay, I'll say this is x1, this is a color is x2, length is x3, diameter is x4, and something like this. So these are 5, 6, 10 parameters of this pen. This is encoded in the form of an array. Okay, this is called string encoding of this design. Okay, how many possibilities are there? No, let us say length cannot be less than 10 centimeter, and cannot be more than 20 mm. So this is the universe of discourse for the length. How much resolution you want? 1 mm, 1 centimeter. So it depends upon your problem. Okay, so depending upon, let us say if I say that it is 10 centimeter to 20 centimeter and the resolution is 1 mm, so there is 100 possible values for this, isn't so? Similarly, the diameter is also going to be, we cannot make it a pen like this size, so we'll have to have some parameter. Universe of the scores for this pen will be there for every parameter, x1, x2, x3, x4, whatever. Okay, within that range, I'll pick up some random number. Initially, very first stage is that I'll take up all these parameter values within that range randomly. I don't know if there is any relation or not. Okay, this is what is called string encoding of this design. Done? Okay. The next is the next starting parameter is fitness function. Now this pen is meant for something what? Writing, comfortable writing rather than only writing. मैं इतने मोटे पेन से भी लिख सकता हूँ, लेकिन it's not going to be comfortable. Okay, so it is to be a comfortable writing. So maybe some other parameter कि भी इसका flow बहुत अच्छा होना चाहिए, इसकी जो length है वो बहुत बढ़िया होनी चाहिए, या कुछ ऐसा कुछ parameter it should be possible कि भी मैं इसको पेन पॉकेट में रख सकूं. So there may be multiple objective, but here I am talking of single objective. That is going to give me the quality of that particular design. Fitness value या evaluation मैं कहूँ कि भी इस design की evaluation करनी है. Okay, so this is called fitness function. I think you can relate with your domain area. Wherever you are working, you are designing some kind of motor, you are designing some kind of switch, you are designing some kind of amplifier, whatever the thing in your area, you might be working on some kind of design. Whatever the design parameters are there, it is to be encoded in a form of string that we call it chromosome, and the fitness function that is going to be evaluated. Okay, randomly I have taken some values. Let us say I will be taking these string values for 20 times. 20 different designs based on random inputs, and now I can evaluate them all, isn't so? Based on the fitness function that they all can be evaluated, and this is called initial generation mechanism. Then evaluate their fitness and rank them. I think there are 20 solutions for one problem. If you compare them, you will find one best, isn't so? And other may be graded accordingly. One poorest, one best, other will be in between somehow. Then we make selection. Okay, selection is to be process whichever design is giving me better performance or evaluation results. I'll pick up that. ये नेचर में कैसे होता है कि जो सर्वाइवल जो फिटेस्ट हैं दे गॉट अपॉर्चुनिटी ऑफ मीटिंग। तो ये जो कॉन्सेप्ट है ये हमने सिलेक्शन में लेके आना है। कैसे करेंगे कि विच एवर इज हैविंग बेटर फिटनेस, जिसकी जो वैल्यूएशन फंक्शन जो है वो ज़्यादा फिट है, परफॉर्मेंस जिसकी ज़्यादा अच्छी आ रही है, आई टेक अप दैट वन एंड गिव इट प्रोबेबिलिटी सम काइंड ऑफ कि बेस्ड ऑन दैट प्रोबेबिलिटी इट विल बी सिलेक्टेड और not selected for the next generation to be parent. Okay, this is the process of selection. I'll go into that, how it is actually done in the form of algorithm. The next step is to create crossover. I'll be selecting two parents randomly based on the probability of their selection that is linked with the fitness value. Then cross over them at maybe multi-point or maybe single point. Mix their genes, whatever the features are. मैंने L1 parent 1 की रखी थी वो कॉपी करके मैंने parent 2 में कर दी, और parent 2 की जो कॉपी जीन्स थे वो मैंने ऊपर कॉपी कर दिए और ट्विस्ट कर दिया। Okay, this is called crossover. Then mutation, some from the whole population 20 solution थे मेरे पास जो नए जनरेशन मेरे पास क्रिएट हुई हैं, दो पेरेंट से दो ऑफस्प्रिंग जो बनी हैं, and I'll be picking some random feature values and modify something to some extent, not exactly all, सारी की सारी चेंज नहीं करनी। पूरी पॉपुलेशन में से हम नॉर्मली 1% या 2% ही करते हैं, it's not done that frequently. Okay, then this is how we get a new generation. This is the last step of this iteration. Sometimes at reaching, while we will be reaching here, we'll be losing our best solution. जो पूरी स्वाम के अंदर 20 स्वाम में थे वो हो सकता है कुछ खराब हो जाए क्योंकि मिक्सिंग करी ना हमने, तो सम सोल्यूशन में गेट लॉस्ट इनटू दैट। टू अवॉइड दैट वी टेक अप ए लाइट सोल्यूशन, वी इंट्रोड्यूस अ लाइट सोल्यूशन। जो पहली पॉपुलेशन में स्टार्टिंग में थे उसमें जो बेस्ट सोल्यूशन थे, अगर वो खराब हो गए हैं तो वापस डाल दो पूरी स्वाम के अंदर से, उसमें से जो वर्स्ट है उसको बाहर निकाल करके नया वाला उसकी जगह पर डाल दिया। दिस इज एक्चुअली लाइटिज्म, ताकि ये एक्चुअली कि आर्टिफिशियल इंटेलिजेंस में हम मॉडल इंटेंशनली करते हैं। आई डोंट नो कि वेदर देयर इज सम बायोलॉजिकल सिस्टम आल्सो और नॉट, बट वी मेक इट लाइक दिस। ओके, तो ये इंटेंशनली जो हम लाइट कॉन्सेप्ट प्रिजर्व करने के लिए है कि बेस्ट सोल्यूशन शुड नॉट गेट लॉस्ट ड्यूरिंग दिस प्रोसेस ऑफ क्रॉसओवर म्यूटेशन। ओके, and then we check whether we have achieved our target value or not, that we want that this design should be like this, and there will be some parameter to make that this is the best design I'll be having. Sometimes we do not have that value even, we just want to have maximum value. You know, let us say कि भाई मैं profit making mechanism design करना चाहता हूँ, मैं शेयर मार्केट के लिए कुछ इन्वेस्टमेंट करना चाहता हूँ। लेट अस से कि देयर आर 20-30 कंपनीज, तो मैं कंपनी 1 में, कंपनी 2, कंपनी 3 में X1, X2, X3, X4 मतलब ऐसे करके मैं एक स्ट्रिंग बना ली कि इस कंपनी में कितना इन्वेस्ट करूँ ताकि मेरे को मैक्सिमम प्रॉफिट मिले। लेट अस से द प्रॉफिट मेकिंग हियर इट इज द फिटनेस फंक्शन। आई डोंट नो, आई डोंट हैव एनी टारगेट, आई वांट मैक्सिमम ओनली। हाउ मच मैक्सिमम इट कैन बी, दिस इज व्हाट इज द टारगेट। I don't have the value that it will be reaching maximum 100 rupees the profit. I can't say that, but this is just an optimization problem that I want to maximize my profit. Sometimes it may be a minimum also, that let us say I want to make some kind of minimization problem. In that case also we'll be having some minimum value, or otherwise you can say that if there is no improvement in the best solution for 100 iteration, then stop it. This is another way to simple terminate your loop. Otherwise this is infinity loop. Either you have reached your target, or you are in a process of infinity and there is no improvement in the best solution, then terminate it. That is another way. How do we do it? Otherwise you can say that okay, I'll be running 100 iteration या 1000 iteration, then I'll terminate. I don't know कि भाई वो कितना improve हुआ या नहीं हुआ, I'm not bothered about, मेरे को 100 iteration के बाद में जो best solution मिलेगा I'll take it. there may be some other parameter or the other mechanism to terminate this loop. Okay, this is the actual flow of the genetic algorithm. In I think computer की जो थोड़ी सी terminology की बात मैं कर रहा हूँ तो ठीक है. Now I'll go into the details of this selection process and crossover imitation.
Every time like candidate करना है और when it is not like when the जो new parent है they are fit parents then वो elect करने की जरूरत नहीं है. If you feel कि
हाँ, otherwise no, it is not required in that case. If you are losing your best solution, in that case,
conditional box
yeah, definitely it can.
There should be a decision box.
Yeah.
If it is required, then elect आना चाहिए. Otherwise, it can
Fitness evaluation, actually fitness evaluation, it is to be done again over here.
Yeah.
Actually, this is the next generation default. I am taking that this is there into that part. Otherwise, without fitness evaluation will not be.
Find the fitness. If the fitness is good, then that same.
Two steps combined into next generation. It's a part of that. Obviously, it has to be there. We'll be just taking that step in case we are losing our best solution. That's the objective of that. Oh, this is what is the parameters that I talked about, how to create a chromosome. I've taken one example of pen design, or you can have another example of market share, market investment into companies, how much amount you want to invest into one company. There may be 10 companies, 20 companies corresponding to that. You can decide that X1, X2, X3 till X20 will be the amount that is going to the respective companies. So that may be the optimization, another optimization problem. Okay, so this is how we encode one solution. This is tentatively one solution that is formulated in the form of array. Okay. Okay, let's take another simple iteration. I'll say that there are 6 chromosomes. Okay, and some having some range values. Say gene 1 is having a range value from 0 to 9, 2 is 2 to 7, and third is having 1 to 5, and something. Let's say I have taken some random values for all these chromosomes. Now this is one chromosome. Okay, and if I add them all, it's going to be 32. Let's say it's a profit making some kind of profit key values जो मेरे को result मिल रहा है वापस. I'm not talking about. This is the fitness function. Just simplicity के लिए मैं आपके साथ में लेके चल रहा हूँ कि this is simplicity. It's the idea that whatever the resultant summation is there, it's taken as a fitness function. It can be some formula also, further formula, a complex formula, but here it is just an idea how it actually going to work in form of variables, and earlier it was flowchart. Now variables and the functions, how they are going to be. Okay, now I think we can appreciate that there are 35. This is the best solution. Then 32, 28, 21, 24, 21, 22. Okay. Now I'll divide that into pie chart. Let's say the area is 100, and area is corresponding to their contribution. Their contribution is going to be the corresponding to the fitness value. What I have done, just added them all. Once I have calculated the percentage of that total, there are, if I add them all, I'll be getting some number. If I divide that every number with that number, total sum, I'll be getting percentage. Okay, this is what is that. 1 to 6 total chromosome, then percentage area, and that percentage area is now shown over as a pie chart. Okay, get that point? It's simple. Actually, I got to select parents for the next generation. For that, I have to have a mechanism like this, that who is having better fitness value should be able to proceed to the next generation. But it is not all the time. It is not all the time. Sometimes weaker solution also get a chance of getting into the parent pool for the next generation. Okay, this is why it is taken as a based on this pie chart, a wheel is prepared and then rotated at a random force. Okay, and one marker given at the lower side, one marker, whatever the segment is coming into that will be part of the next parent pool, next generation parent pool. I think now we can have that idea. Probability, fitness value, and possibility of selection is in one line. If the fitness value is more, probability of selection is more. But it is not like this that the poorest will not be selected. Maybe selected there. Chances are less. Okay. So this is actually the concept of natural phenomena. Okay. Now, then we randomly make groups. It will be better that if having more fitness and in one group parent pool, then solution corresponding to their offspring will be better. Okay, so this is what is just randomly I picked up and made a parent 1, parent 2, parent 3, parent 4 and grouped them into 2. Now there will be crossover. Before that I'll have to generate some random numbers. These random numbers will be nothing but the points of crossover. This is single point crossover. Simple idea, single point crossover. एक और क्वेश्चन होता है कि क्रॉसओवर करना है या नहीं करना. That is also one issue. 99%, 95% से 99 के बीच में हम रखते हैं इस नंबर को. This is going to be a crossover. This is going to be crossover. कि क्रॉसओवर करना ही नहीं है या नहीं करना है या नहीं करना है. That is also to be decided. अगर करना है तो किस पॉइंट पे? तो स्ट्रिंग की लेंथ कितनी है उसके बीच में एक रैंडम नंबर इंटीजर नंबर को भी जनरेट कर लीजिए. And after that you make twist into that. ऊपर वाले शिफ्ट कर दिए नीचे और नीचे वाले ऊपर. It's a twist at that point only. इसी पॉइंट के ऊपर ट्विस्ट कर दिया. This is called crossover. Single point crossover. मल्टी पॉइंट भी कर सकते हो, यूनिफॉर्म भी कर सकते हो. ये हर एक पॉइंट के ऊपर आप डिसाइड करो कि क्रॉसओवर करना है या नहीं करना. Create a bit of let's say there are कितने string length is 8. To create 8 binary numbers. First binary number if it is 1, then make crossover. Second, if it is 0, don't make crossover. If it is 0 again, don't make crossover. If it is 1, then make crossover for 1 bit only. This is called uniform crossover. There are a variety of crossovers. Market में आप थोड़ा सा literature survey करोगे, you'll be getting lots of varieties on crossovers only. Single point, multi-point is most popular depending on your problem. Now, this is what is the strategy parameter. Once you take up your problem, I was talking in the initial stage of this discussion that once you choose one algorithm for your problem, you'll have to carefully decide what is going to be the strategy parameters. Single point crossover होगा, multi point होगा, कितने point रखने हैं, या आप चाहते हो कि इस point को तो करना ही करना है. You can force also. Depending on your requirement, if you feel like that. Okay, this is the concept of crossover. Now, getting genes mixed, and this is the no, it's not actually the parent. Now it is children. Child 1, child 2, child 3, child 4, child 5. You take it like this. This is not now parent, but actually, once we make a small change, let's say this was supposed to be gray. But now it is modified. Why modified? New feature added into that is not available in the parents. This is actually the process of exploration. Exploration and exploitation are two important features of every algorithm. Every optimization algorithm must have two features. One is exploitation. Whatever the feature values you have, you just make all the combinations. And that combination should be experimental in such a way that you should get your results at the earliest possible. This is exploiting all these features. Then exploration, some new feature values, those are not existing into this. Okay, so this is how you can experiment this thing. Mutation is creating some new feature values, those are not existing. Now next time this will be a part of this. This is the new generation. This is now the child 1 to 6. Okay, so next time you will be having one feature that is new to this kid, this kid, and this kid. Okay, this is called mutation. Some features of the kids itself that is not that was not present in the parent pool. Okay, so this is the concept of. Now this process is to be repeated once again. Now this is going to be the next generation. Now this next generation will act as a parent pool for next iteration. You know, human beings are on earth for a long years, and this process is improving and still improving. And this is what is the scenario that हमारा जो लाइफस्टाइल है, जहाँ हमारे पास जो इंफ्रास्ट्रक्चर है, जहाँ हमारे पास जो अंडरस्टैंडिंग मैकेनिज्म है, जहाँ लर्निंग एटीट्यूड है, जहाँ मैकेनिज्म है, दिस इज इवॉल्व्ड ओवर years. Now how to mimic this? This is what is discussed here into the form of algorithm. Now this algorithm can be used for solving our engineering problems, because computer can iterate this process within seconds, maybe sometimes fractions of seconds, and this process 100 iterations, 1000 iterations, you can do it on a computer within a minute, and your solution will be available, isn't so? Let us take one example. Traveling salesman. It's a very popular, it's one of the benchmark functions now, you can call it. Its scenario is something like that. The one salesperson has to travel, let's say, 10 nodes. Objective is to find out the minimum total distance should be minimum in to identify one path where the total traveled distance should be minimum. Obviously time will take should be minimum. Some people have investigated the same problem, that giving a path value also, that this is a costly path and this is a cheaper path but long, and corresponding, you know, some alteration, some modification, people have, you know, experimented on that also. But for the simplicity, for single objective, you can take only one parameter, that the distance is only one significant parameter that is going to contribute. Otherwise you can make it multi-objective or multi-constraint parameter. That's what is possible. One node is to be traveled only one time. Okay. Okay, I'll take you to the MATLAB environment after this GA. Okay, I think let's take only 4. How GA will solve that? It will travel all these nodes and will identify this one. Let's say I'll add some more. Sorry, I have to stop. This iteration process keep on going. You can choose location of the nodes, and then whichever the best path will be highlighted. This is happening in a very small time, you know. मैं एक क्लिक करता हूँ, साथ के साथ रिजल्ट आ जाता है, because computer is not taking much time to handle this is small number. If it would have been 1000 dots, I think it will take a lot of time, but मैं कोशिश करता हूँ कि भाई sufficient सा number आपको दिखा दूँ. It's taking a bit time more as compared to the previous case. It will identify all the paths. This same problem has been solved using ACO also, ant colony optimization. That ant colony optimization is very popular in what do you say, movement of packets from source to destination. We want to identify a path where the delay is minimum, and that is applied into the networking also. Okay. This is what is the experimentation. Now you can see how actually it runs. It is all experimenting, making permutation combinations so that all the nodes should be traveled, and ultimately constraint is there that every node has to be traveled only one time. Okay, so this is the way how. Otherwise, can you imagine how many कितने नोड्स यहाँ पे शायद मुश्किल होगा. लेट्स से कि 25 नोड हैं. 25 नोड अगर हैं तो how many possibilities are there? How many possible routes can be there with the constraint that every node will be traveled only one time? So it's a big number. 25 nodes, 25 string length, and it won't be possible to handle it. कॉम्बिनेशन की भी उसमें से मेरे को बेस्ट वाला सोल्यूशन ये चाहिए कि भाई जिसमें मिनिमम डिस्टेंस ट्रैवल करी जा सके. तो ये चलो ये आपको एक एग्जैक्ट सोल्यूशन दे देगा. अदरवाइज रियल लाइफ में देखूंगा अगर थोड़ा बहुत प्लस माइनस भी चलता है तो इट इज एक्सेप्टेबल. इट्स नॉट दैट बिग इशू फॉर ह्यूमन, बट विद दैट कंस्ट्रेंट अगर हम इसके वजह से फॉर्मूला की बात करें तो इट्स वेरी गोइंग टू बी वेरी कॉम्प्लेक्स. ऑल्दो इट्स लीनियर, पैरामीटर नंबर ज़्यादा है, लेकिन सॉल्व करना टीडियस काम होगा. लेकिन आर्टिफिशियल इंटेलिजेंस में एवोल्यूशनरी एल्गोरिथम GA हैज गिवन दिस सॉल्यूशन इन अ वेरी इफेक्टिव टाइम, यू कैन से. Okay, this is how we handle our problems. Okay, any query till this time? Fitness function, जैसे मैंने अभी आपको बताया कि in this case the fitness function is the total distance traveled. You have nodes, XY coordinate parameters are there. You can identify the distance between the two nodes. What is the total distance that is traveled by a traveling salesperson? It's all the addition of this all. In your case of own domain, you'll have to check that your application area, how you are going to evaluate that design. Let us say I design one engine. Obviously there are number of parameters into that. तो मैं इंजन की एफिशिएंसी की देखूंगा, माइलेज कितनी मिलेगी मेरे को से इंजन से, पावर कितनी मिलेगी, मल्टी पैरामीटर्स हो गए ना. तो अगर मैं दोनों को बेस्ट निकाल सकता हूँ कि माइलेज, देखिए नॉर्मली क्या होता है कि अगर मेरे को पावर ज़्यादा मिलेगी तो माइलेज नीचे चली जाती है. तो अगर मेरे को माइलेज भी ज़्यादा चाहिए और व्हाट यू से पावर भी ज़्यादा चाहिए और माइलेज भी दोनों ज़्यादा चाहिए, तो वो डिज़ाइन मेरा बेस्ट होगा. दैट इज द टारगेट मल्टी ऑब्जेक्टिव प्रॉब्लम्स. आप सिंगल ऑब्जेक्टिव की बात करोगे भी मेरे को सिंगल ऑब्जेक्टिव चाहिए, मैं कार लेने जाता हूँ. ओके, तो कौन कौन से पैरामीटर का ध्यान रखता हूँ? देयर आर मेनी पैरामीटर. माइलेज है, बहुत इंपॉर्टेंट है, और फ्यूल टाइप क्या है, एवरेज जो उसकी लुक्स कैसी हैं, एक्सटीरियर लुक्स कैसी हैं, वेरी राइटली पॉइंटेड आउट कि सेफ्टी फीचर्स क्या हैं, एंड ऑब्वियसली द बिगर वन द कॉस्ट. देन वी ऑप्टिमाइज दैट. मेरे को मिनिमम कॉस्ट, मैक्सिमम फीचर्स, मैक्सिमम माइलेज, तो बहुत सारे पैरामीटर्स हैं यहाँ पे मेरे को जो ऑप्टिमाइज करके निकालने हैं. देन आई फाइनली टेक. फिर कलर की बात आती है. कलर के लिए तो हम यही बोल देते हैं, बच्चों को बोल देते हैं कि बताओ ये वाला रेड वाला है या ब्लू वाला है. तो these are all parameters that we want to optimize, okay, based on various parameters, input parameters are there. Okay, this is obviously this is fitness function is always application specific, domain specific. We cannot make it generic. हाँ, कुछ ऐसे मैकेनिज्म हैं, जैसे अगर मैं कहूँ कि मेरे को टारगेट डेटा मिल गया कि ये मेरे को अचीव करना है और मैं आउटपुट कैलकुलेट कर सकता हूँ. ओके, लेट्स से कि आई हैव अ लिस्ट ऑफ आउटपुट वैल्यूज कॉरस्पॉन्डिंग टू सम इनपुट्स. ये मेरे को इनपुट देने पे ये आउटपुट मिलनी चाहिए, ये इनपुट देता हूँ ये आउटपुट. आई कैन हैव ट्रेनिंग डेटा, यू कैन टॉक ऑफ कि भी इनपुट दी, आउटपुट ये आनी चाहिए, लेकिन नहीं आई, सिस्टम ने ये दी, तो वहां पे आपके पास जो आनी चाहिए थी जो आई, दोनों के बीच में एरर होगा, डिफरेंस होगा ना. अगर वो डिफरेंस 0 हो गया, इट मींस कि यू हैव डन योर थिंग. लेकिन ऐसा नहीं होता इनिशियल स्टेज में. रैंडमली जब हम स्टार्ट करते हैं तो वो डिफरेंस को हमने मिनिमाइज करना है. वो डिफरेंस ये आपका ऑब्जेक्टिव फंक्शन बन जाएगा उस केस में, isn't so? वो स्ट्रेट फॉरवर्ड सी एप्लीकेशन बन जाती है जिसमें हम आरएमएससी की बात कर लेते हैं, या मीन स्क्वायर एरर की बात कर लेते हैं, या एब्सोल्यूट एरर की बात कर लेते हैं. दैट इज वे, वो एक ऐसा एल्गोरिथम है, एक ऐसी अप्रोच है, वो काफी एप्लीकेशन में फिट हो जाती है. बट हमेशा हो गए इसकी कोई गारंटी नहीं है. देयर इज नो हार्ड एंड फास्ट रूल, नो थंब रूल दैट दिस विल बी एप्लीकेबल ऑल द टाइम. Yes, any other query? Sorry? Yeah. Yeah, it is. Actually, we want to make maximum exploitation. Actually, there is some investigation studies into that also. In initial stage, we make exploitation maximum. Once that saturates, result is not improving, then we start exploring. Mutation is increased. Mutation is increased. I have experimented with BBO where we have made mutation 50% and resulted in very good performance. Overall result was very good. Starting case, we were having exploitation more, migration of species from one place to another, or using crossover is maximum starting. Once that is सैचुरेटेड समटाइम कि इसके बाद में इंप्रूवमेंट नहीं हो रहा, देन क्रॉसओवर की जगह पे क्रॉसओवर को हमने उतना ही रहने दिया, म्यूटेशन बढ़ा दिया. दिस रिजल्टेड इन वेरी गुड रिजल्ट गिविंग मी. और एकदम से नए आपके पास फीचर्स ऐड होनी शुरू होगी जो पहले आपके पास एग्जिस्ट नहीं करती थी. एक्चुअली वंस अगेन इट्स अ स्ट्रेटेजी पैरामीटर दैट इज स्पेसिफिक टू योर प्रॉब्लम. You have to experiment while you are solving some problem. You'll have to experiment that which value of mutation is most suitable to your initial experiment to give you an idea that what should be the mutation rate. I was also having that idea that in biogeography there is very similarity into that, but it is one directional. Biogeography में यहाँ पे crossover में two directional फीचर एक्सचेंज है. बायोजियोग्राफी में वन डायरेक्शनल है. मैक्सिमम फिट से मिनिमम फिट की तरफ ही फीचर्स कॉपी होती हैं, अदरवाइज इट इज सिमिलर. आफ्टर सम टाइम इट बिकम सिमिलर. सारी पॉपुलेशन एक जैसी बन गई, कॉपी हो करके आफ्टर 1000 आइटरेशन वो सारी की सारी पॉपुलेशन एक जैसी बन जाएगी. तो उसको अवॉइड करने का यही तरीका था कि आप मैक्सिमम उसमें म्यूटेशन डाल दो. दैट रिजल्टेड इन wonderful results. One Yagi Uda and Tina were designed using this algorithm. Okay. Any other query? Mutation parameter, crossover parameter. Approximate values are given like this, that keep more than 95 crossover and less than 5% for mutation. But it is not hard and fast rule. There is no hard and fast rule. This is the most of the result जो हमारे के इन्वेस्टिगेशन से मिले हैं, उन्होंने अच्छा परफॉर्म किया है इस तरह के पैरामीटर. इन आर्टिफिशियल इंटेलिजेंस डोंट टेक एनीथिंग हार्ड एंड बाउंड, है ना, ये ऐसा ही करना है, नहीं. म्यूटेशन देखिए एक सिंपल सा है कि अगर म्यूटेशन आपने 100% कर दी मींस दैट इज अ रैंडम सर्च. you'll have to take care of that idea also that it should not be a random search. ऐसा नहीं हो कि तुक्के मारने शुरू कर दिए. There should be some logic for that also. That a crossover is also going to contribute. अगर if you increase the mutation to 100%, then crossover concept is lost. You'll have to take care of this. Okay. Next is about okay, bird flock है. This is about particle swarm optimization. I think you might have seen this type of scenario.
We have lost our connections.
सर पानी मिलेगा
सर पानी का कॉल कर दो
पानी के लिए कॉल करो जी
थैंक यू वो प्रोसेसर की प्रॉब्लम है ना इसलिए भी i3 है सर C3 पे रिक्वेस्ट है हाँ ठीक है
वैसे आप लोग कौन कौन से एरिया में काम कर रहे हैं मतलब कैन यू नेम समथिंग योर एरिया ऑफ रिसर्च आई थिंक मोस्ट ऑफ द पीपल विल बी फ्रॉम रिसर्च बैकग्राउंड आई सपोज आपका तो अच्छा मीनाक्षी आप भी बैठे हैं आपका कौन सा डोमेन था डेटा माइनिंग पावर इलेक्ट्रॉनिक्स हाँ सजन चल रहा है अभी हो गया ना आपका तो हाँ
किसके लिए मेरे एप्लीकेशन के लिए मैंने तो जैसे GA मैंने ले लिया बट एक्चुअली से अभी आपका जो फायरफ्लाई है ऐसे whether it will suit me whether I have to apply and see or how do we decide which algorithm I have to use for my form
वो एल्गोरिथम की बात नहीं समझ रहा एक्चुअली एल्गोरिथम के अंदर कितना देखिए एक छोटा सा एग्जांपल लेते हैं अगर आपको एक ही सॉल्यूशन चाहिए तो आप
हेलो हेलो
हेलो यस सर
सर आवाज आ रही है सर
यस सर
सर एक मिनट सर क्वेश्चन करेंगे सर
हाँ जी सर
Sir, good morning, sir.
मॉर्निंग गुड मॉर्निंग
Sir, this is from Modi University, Dr. Sudhir Y. Kumar.
जी
Sir, I would like to ask you one question
यस
on this optimization. Sir, is there any minimum, this is any specific condition why we do that minimum objective function for a particular application? There is any specific
I'm sorry why
minimum or maximum objective function is to be
Okay.
taken care?
Okay, I have discussed one example of profit making problem. I think we'll be taking it as a maximization problem. Huh?
Yes,
if you
sir.
want to consider minimization problem, say error minimization is one scenario, you can make it a maximization problem. 1 upon error, it's a maximization problem. Are you getting point? If you make it fitness function equal to 1 upon error,
Yes.
yeah, 1 upon 1 plus error, RMSE you can talk of.
Yes, sir.
This will become a maximization problem.
Hmm.
Okay. No, there is no hard and fast rule that you will be dealing with all minimization problems or maximization problem. You can modify uh, any problem into minimization or maximization problem.
Okay. So in general, sir, what are the different types of objective function? Hello?
Hanji. Broadly saying, there are single objective and multi-objective. This is one way of classification.
Okay.
The another way that depends upon your application, that it is maybe formula based or maybe data based.
Mhm.
You can design your optimization function that may be derived from data or it may be derived from formula.
Okay. Thank you. Thank you.
Good morning, sir.
Good morning.
This is Pramod Bhatt from Modi University. Sir, out of the mentioned algorithms, I want to know whether the genetic algorithm is suitable for adaptable system. I mean, I'm working on the smart grid system where the parameters are online coming. So, is the genetic algorithm suitable to optimize the system on the online basis and adaptable also?
Adaptive parameters.
To
Okay,
adapt
you want it to be online supervision, online optimization.
Yes, bro.
Yes.
Are you talking of on real-time optimization?
Yes, sir. Real-time parameters are coming,
Yes.
and
Okay.
simultaneously, I am getting the optimized results. Is
Mm-hmm.
like optimal power flow analysis.
Mm-hmm. Got it. Okay, there are some problems where we need to optimize our decision after every iteration. Uh, let's say that this scenario of ad hoc networks also, I want to transfer my data from one node to another node. These nodes are also moving. Then this type of scenario is demanding optimization of the path in real time. Most of the time we have applications, those are offline applications where I have to decide only one path one time, and that is to be done at the very initial stage. Then we just make use of that solution. But this is the scenario that is possible. GA can solve this problem, but one has to be very careful that all the number of iteration has to be limited to some specific small number, so that all these iteration can be completed in time and you will be getting some results. Your fitness function should be in such a way, it should be designed in a way that computationally should not be very intensive. Let us say RMSE is there, and if RMSE is going to be calculated for 1 lakh error differences, then it will take a lot of time. If it is some tens of numbers that whose error is to be calculated, then it's okay. It can be done on real life. GA is actually algorithm. Most of the things are algorithmic. PSO is having two equations that is formula based. That's why in this discussion I talked about that we most of the time look for algorithm. Those are mathematics, some background for that. We try to formulate some mathematical formula for the inner functions of the biological, the logics, whatever we are falling into. But it is not always possible. But wherever it is possible, just like PSO, it is possible with that PSO that you can have calculations based on some mathematics, and it is done faster with the computer also. Wherever we need algorithm, it is done a bit slower. You'll have to take care of your application if you are working on real life application. Be careful about that. Calculation should not, iteration should be limited. Am I clear?
Thank you, sir.
I think now we will go for a short tea break and then we will again come. All the centers also, please, you can go for the tea break. And after some 15 minutes, we'll reassemble. Okay, 11:45 we'll reassemble. Now it is 11:34. So at 11:45 we'll reassemble.
मेरा क्या था, बार बार हम लोग मिनिमाइजेशन में जाते हैं। मिनिमाइजेशन में क्या होता है, एडवांटेज एरर आरएमएस एरर है ना, एरर में एरर मिनिमम कर देते हैं। वो तो सिलेक्शन और फिटनेस फंक्शन को डिपेंड करता है ना, क्या तो हमारा भी कंट्रोल सेक्शन में सारा एरर ही ऑब्जेक्टिव फंक्शन होता है, 7-8 तो उसका ऑब्जेक्टिव फंक्शन यूजुअली हाँ जैसा लिखते हो उसके ऊपर
ये तो हमारा हो गया। ओ इधर बंद करो। अब ये कैसे जाएगा? इसे ऊपर ऊपर स्क्रीन पे जाओ ना। कहाँ से? उसी पे दोबारा क्लिक करके दोबारा ये कर दो ना। नहीं आ रहा। नहीं, हाँ ये दिखा रहा है ना ये, हाँ।
कर सकते। Okay. Okay, there is one query about fitness function. This fitness function is almost applicable to all optimization algorithms. Same fitness function can be used in almost all applications. Okay, this is one category of fitness functions that is based on the errors, where we have some input-output data. We can take it that this is input data and this is output data. This is the target value. This is the computed value. For every input, you'll be having some target value and some computed value. You calculate RMSE of that. You know, root mean square error value. That is the most popular method. RMSE. Then absolute error. We are not making scale of that. Absolute error. And relative, some kind of percentage of error, that is something. And mean or relative absolute error. Okay. For example, okay, Madam Shami has pointed out that one problem is there. I take it another way. You can optimize a fuzzy logic system. How do we do it? Why we optimize a fuzzy logic system? There are some reasons for that. Otherwise, we see it as a common sense or some experiential knowledge that is encoded in the form of number of fuzzy sets and rule base. Okay, if I ask some simple question, I think most of the audience might be familiar with the fuzzy logic system. We have fuzzy sets into that, and their interconnectivity through rule matrix, and then output fuzzy sets, and their relation with the rule matrix and input fuzzy sets is through a defuzzification method. We identify some output in nutshell. But how many fuzzy sets has to be there? What should be the number? How many input parameters are there? You can take it from the application. How many fuzzy sets will be there for every input? I think there is no hard and fast rule once again. That depends upon the application. And if you want to take very large number of decisions, after a small change you want to take some decision, then you'll have to have more fuzzy sets. That is only the rule. This is only how we decide. If we are not bothering about significant changes into the outputs, then we can have less number of fuzzy sets. Then another question is, what should be the number of rules? Also, let us say there are 5 input parameters. Each 5 input parameters are having 5 fuzzy sets in each. Then total number of rules will be 5 raised to power 5. 125 rules. 125 rules, can you make it manually? It's very difficult. Then we take most significant rules. Those are of the obviously very relevant to the problem. We take 5, 10 or some maybe bigger number 25. But if you say that there one another fuzzy set is added into the inputs, rule will become about how much it will be 5 raised to power 6. It's quite large number. One change will make a lot of change in the rule base. How many rules and which rule is to be picked up? That is one. Another scenario, what should be the shape of the fuzzy sets? क्या वो सारे के सारे एक जैसे हों? क्या वो अलग अलग शेप के हों? किसकी कौन सी शेप होगी? How to decide? हाँ, first set and last set can be open ended. That's to some extent it is acceptable. But what about the in between? Triangular होगा, Gaussian होगा, symmetrical होगा, unsymmetrical होगा, trapezoidal होगा, whatever. There are varieties of options there. And definitely the shape and the location of the fuzzy set matters while deciding the rule base. Rule base is dependent upon the shape and the location of the fuzzy sets, input fuzzy sets. Another parameter, okay, you have decided that there will be 5 input fuzzy sets in a one input. क्या वो सारे के सारे symmetrically distributed होंगे? How to decide once again? वो unsymmetrical है या नहीं है, that is a separate issue. What should be the location of that fuzzy set? क्या वो पूरे universe of discourse के ऊपर equally distributed होंगे या कुछ congested होंगे, कुछ broader होंगे? So that is all research areas open for discussion while you are talking of one simple fuzzy system. Okay, मैं शायद ज़्यादा इसमें चला जाऊँगा तो आपका एक टॉपिक है फजी लॉजिक के ऊपर. I think that will address all these issues. The point of discussion is that you can make use of optimization algorithm in solving this problem. I have some knowledge, I have some idea, but if you ask me relate that, it will be very difficult to relate every knowledge into the fuzzy sets, location, shape, and role base. Isn't so? And if I am not able to explain, then how I am going to design that also? That is also issue, because it will become very complex once you increase the number of fuzzy sets. Okay, this is one scenario where your designing fuzzy system becomes a very NP hard problem. And in this case, we can have a mechanism like this, that I want to design one system, a fuzzy logic system, for some controlling of a plant, let's say existing plant. I have records of the data कि इसमें ये इनपुट आती थी तो ये आउटपुट आ रही थी, जो मेरे लिए बहुत बढ़िया थी. पहले किसी ने डिसाइड किया होगा, लेट अस से पीआईडी कंट्रोलर बनाया हुआ था to control one plant, and I have some input output data. Now control parameter has been changed. PID controller काम नहीं कर रहा है, जहाँ you want to replace with fuzzy logic system because it is expected that it can give better results. That data with some minor changes, जहाँ पे आपको लग रहा था कि ये डेटा में यहाँ पे आउटपुट सही नहीं आई थी, so you can alter that. After now you have new data that is not having the problems of PID controller. Now you want to design that fuzzy logic system for your problem. So this type of functions will be useful there. You design arbitrary fuzzy system. Let's say give a string. Now the string will be, what will be the shape of the string? Okay, मैं सर्च कर लेता हूँ, एक पीपीटी पुरानी पड़ी हुई है, तो मैं आपको उसके बारे में थोड़ा सा बता देता हूँ, थोड़ा सा विजुलाइज हो जाए तो विल बी मोर यूजफुल. ओके, Actually, this is the PPT presentation of my PhD submission that happened in 2011. I'll show that. Some portion will be coming up in this PPT also. Yeah. Designing a fuzzy system itself is a NP-hard problem. Why it is NP-hard? Because there are large number of parameters involved. How many parameters are there? Let us say one fuzzy set is represented by two parameters, two supports. Suppose that is symmetrical. If it is not symmetrical, then peak has to be there. Okay. Or if it is trapezoidal, then 4 parameters has to be there. For the simplicity, let us consider that it is symmetrical and having 2 parameters to represent first end and the last end of the fuzzy set. Okay, 2 parameters for one, and one will be the shape. Let us say one, you can say integer 1 is for triangular, Gaussian, say 2, and corresponding to shape you can give some numbers. There are 3 parameters will be required for one fuzzy set. Okay, let's say there are 4 inputs and each fuzzy set is having 4 parameters, for 4 fuzzy sets also. How many parameters will be required to describe input fuzzy sets only, inputs only? One fuzzy set will require 3 parameters, 4 fuzzy set will require 12, okay, and 4 inputs are there, 48. 48 will represent inputs only. Now let us say that there is some output also. Before that, let's consider one output, let's say, so that I can freeze the rule base. One rule will be consisting of how many parameters? 4 input में से कोई एक fuzzy set होगा. 4 plus 1 output. 5 parameter will describe one rule. How many rules will be there? 4 raised to power 4. Maximum. Let us say I'll take 10 for the simplicity. One rule is represented using 5 parameters. Actually, this is formulated in form of a formula. N is 4, 4 plus 1 singleton output, and number of fuzzy sets. First, this is the first endpoint, second point x2, then shape. 3 parameters will be required. Shape 1, Z shape, triangular 2, Gaussian 3, and S shape. For the simplicity, this is just how many consequents are there? 1 consequent, non-singleton अगर fuzzy set लेते हैं तो 3 consequent लिएगा. Okay, this is the string length for the inputs. This is for the outputs. Let's say there are 5 outputs values and their locations corresponding to that. Their number of 3 parameter अगर 3 fuzzy sets को हम दिखाना चाहते हैं, 3 fuzzy set के parameters को दिखाना चाहते हैं. एंड रूल बेस, जैसे अभी आपको बताया कि 4 इनपुट हैं, 1 आउटपुट है, और कितने रूल हैं? 10 रूल हैं, तो 10 के साथ वो मल्टीपल 50 की स्ट्रिंग लेंथ हो गई. इनपुट्स fuzzy sets 45 was list, I think. Then 50 total length is 95. 95 is the string length of a. Now, if you want to go for ending ORing के अंदर भी बहुत सारी option है, या defuzzification के अंदर भी बहुत सारी option है, which one you want to opt for, so you can even increase the number. This is for type 1 fuzzy system. String length is 95. Okay, this is how we encode a fuzzy logic system as a chromosome. Then we randomly give some values. Obviously, every element, every gene is having some universe of discourse. Fuzzy sets cannot have value less than 0 or greater than 4. To some extent, if you want to say that it is going to contribute there in the rule base, you can have -1, -2 also, negative, where we say that if this not, then this. No, rule may be like that. Simplicity के लिए हमने इसको rule base को ये किया कि जो parameter shape के corresponding है, it cannot have value beyond 1 to 4, and it will have only integer values. Okay, so this is how we encode our string length. ये एक सिनेरियो था जिसके अंदर मैं जिसकी बात कर रहा हूँ. 4 इनपुट है, 1 आउटपुट है, अरे के लिए 3 फजी सेट चाहिए, 20 रूल लिए हैं, तो स्ट्रिंग लेंथ इतनी बन रही है. नॉन सिंगलटन के लिए और नॉन सिंगलटन के लिए इतनी. ओके, 20 रूल हैं, इसलिए थोड़ा नंबर बढ़ गया है. एंड ऐसे टाइप 2 के लिए भी हम काम कर सकते हैं कि टाइप 2 के लिए भी रिप्रेजेंटेशन है फजी सिस्टम के अंदर. एक थोड़े से एडवांस्ड वर्जन है. एक फजी सेट को आप 7 पैरामीटर से रिप्रेजेंट कर सकते हैं. देयर इज अनदर रिप्रेजेंटेशन जिसमें 6 के साथ में कर सकते हैं. देयर इज अनदर रिप्रेजेंटेशन जिसमें 4 के साथ में भी कर सकते हैं. ये बहुत सारी वैरायटी है. स्ट्रिंग लेंथ उस हिसाब से एडजस्ट हो जाती है कि भी कितने रूल कितने वाला. एक सिनेरियो के लिए कर रहे हैं 4 इनपुट 1 आउटपुट 20 रूल. ओके, और उसके कोरस्पॉन्डिंग स्ट्रिंग लेंथ सिंगलटन है, नॉन सिंगलटन है, और सिंगल सेट के लिए है, एक फजी सेट के लिए. ओके, तो ये पीएसओ के बारे में बाद में आएंगे इसके बारे में. तो दिस इज द वे हाउ वी इनकोड आवर प्रॉब्लम इन द फॉर्म ऑफ स्ट्रिंग. अब ये आपका फजी सिस्टम हो सकता है. फजी सिस्टम अपने आप में एक आर्टिफिशियल इंटेलिजेंस का एक पार्ट है, but there are many limitation to this application that we don't know most of the things, that what should be the shape of the fuzzy set, how many fuzzy sets will be sufficient for solving this problem, and how many rules will be appropriate for. देखिए ऐसा ना हो फजी सिस्टम का ऑब्जेक्टिव जो बेसिक ऑब्जेक्टिव है तो मेक अप्रॉक्सीमेट कैलकुलेशन, हम उसके अंदर रूल बेस ज्यादा करते हैं बड़ा, और रूल्स नंबर ऑफ रूल्स जो फजी सेट्स हैं वो इंक्रीज कर दें, प्रिसीजन कैलकुलेशन के चक्कर में पड़ जाएं, तो बेसिक जो ऑब्जेक्टिव था फजी लॉजिक का वही खत्म हो जाए. फजी लॉजिक इज मेंट टू हैंडल अनसर्टेनिटी, नॉट टू क्रिएट complication and making calculation, and that is time consuming calculations. That is not the objective. Actually, this is the problem that I had solved during my PhD work. And in this scenario, what happened actually, one system was to be evaluated on 500 input output data points. And MATLAB environment itself is a bit slower as compared to C language. One iteration of 20 chromosomes were there, 20 systems, fuzzy systems were there, and every fuzzy system is to be evaluated on fitness function, and fitness function is having 500 data points. And one iteration 1 to 20 chromosome की सभी की evaluation करने के लिए 15 मिनट लगते थे. I was supposed to run this thing for 10,000 iteration. It was bottleneck problem. I could understand at that time that MATLAB is very slow. After 6 days, I have to stop my this algorithm and then see. पहले बार तो मैं एक्सपेरिमेंट किया तो I was not able to understand that कि मेरे को जो रिजल्ट आएंगे वो ठीक भी होंगे या नहीं. मैं 6 दिन तो हो गया मेरे को लेकर के बैठे हुए लैपटॉप को. चार्जिंग की प्रॉब्लम, पावर की प्रॉब्लम, that is the all additional problem during your research. And that is what I realized at that time, that okay, MATLAB is good, it is friendly, user friendly, and gives you a lot of support, but it is slow. After 6 days, I have to terminate. Then I have to re-examine all the results. Then I identified some problems and identified the function that was taking time, especially this fitness function. It was taking a lot of time. Then I coded into C, made that time, calculation time reduced. Then redo the same thing. Then it was done in a reasonable time. Even the results were also preserved after every iteration. It is to be written into a data file so that I can check it later on. These are the things that you realize once you are into the research. This is the scenario that was. Okay, I think you might have get the idea that how to optimize engineering system, how it can be encoded, how it can be corresponding to that fitness function can be evaluated. Okay, evaluation of a fitness function is something, you know, you'll have to understand the concept of fuzzy logic running also. You give some input, implications are there, clipping is there, fuzzy sets कौन से clip हुए, उसके corresponding कौन से rule fire हुए, then उनकी aggregation करी, then defuzzification करी, then you will be getting one output. 4 input, एक output तब मिलेगी. फिर आपको टारगेट के साथ में कंपेयर करनी है कि एरर कितना आया. This is one error. 500 times this is to be repeated. Now this coding of a fuzzy system has to be done in C, and so that C is quite fast. The same problem was taken up by another my colleague, my teacher. She has taken that problem and solved the same thing on C, whole problem on C. I was taking 15 minutes and she took 2 seconds in C. That is the difference. Then the same problem was solved on GPU also, making it parallel. All rule firing is made parallel. Then it is 0.3 seconds. Oh, you know, we have wasted a lot of time on just making calculation and all, but this has given me a lot of idea how the parameters are related, how the rules are behaving. Still the performance after doing this a lot of calculation, I understood that even better approach can be experimented. What we have done, this is one of the researchers is now almost at the verge of completion of that idea. What we have done, we have frozen the shapes and the location of the fuzzy sets by making it symmetrical and data driven. One fuzzy C means clustering algorithm is there that can be used for deciding clusters, and that clustering can be used for designing fuzzy sets. Okay, now you have very logical mathematical tool for you, and that is to be done only one time, and we froze that all inputs parameter. Now you have left with a very small string parameter, string length, about 50, maybe maximum अगर 20 अगर parameter 20 रूल्स ले रहे हैं तो 100 की स्ट्रिंग लेंथ रह जाएगी, आधी रहेगी तकरीबन. एंड नाउ रिजल्ट्स आर कमिंग बेटर, परफॉर्मेंस इज गेटिंग इम्प्रूव्ड. ओके, नाउ सिर्फ रूल को ही इवॉल्व किया है, बाकी सब कुछ फ्रीज कर दिया. एक तो कि जल्दी हो रहा है, रिजल्ट्स भी आ रहे हैं और कैलकुलेशन टाइम भी मतलब आपका रीजनेबल है. नाउ वी आर एक्सपेरिमेंटिंग विद, जैसे मैंने आपको बताया कि टाइप 2 के साथ में भी एक्सपेरिमेंट किए. उसमें भी हमारे को, उसमें क्या है कि हम करप्टेड डेटा के साथ में प्रॉब्लम काम सॉल्व करते हैं कि योर डेटा इज वट एवर द डेटा. जैसे मैंने कहा कि मैंने पीआईडी कंट्रोलर से लिया, पीआईडी कंट्रोलर में कुछ ना कुछ सेंसर मैकेनिज्म होगा जिसने मेरे को रिकॉर्ड करके दिया डेटा. इफ आई एम नॉट श्योर अबाउट दैट डेटा, इफ इट इज नॉट you say that it is already corrupted with the noise of the sensor itself, then whatever the system you will design will not be suitable. Now problem, this is actually a real life problem. Once you are required to design a system, you'll have some data, and what is the certainty of the data? क्या वो बिल्कुल एक्यूरेट है, उसमें कोई प्रॉब्लम तो नहीं है? क्या वो पैरामीटर की आउटपुट टेम्परेचर या कुछ और फिजिकल पैरामीटर पे तो डिपेंड नहीं कर रही? If it is like that, then you'll have to take care of. Now the objective is, जो फजी लॉजिक के ऑब्जेक्टिव भी हैं कि करप्टेड डेटा से आपने एक सिस्टम डिजाइन करना है जो एक्यूरेसी के साथ में काम करे. Isn't so? No, that is very realistic. I want to make money from the share market, let's say, and I have some experience, but not exactly वो experience मेरा वैसे काम करता है या नहीं करता. Can we design a fuzzy logic system that can give me a forecast that this share is going to get more value within this period of time? This is a very good research problem. Can we make some kind of forecasting mechanism? I want to, let's say, forecast weather forecasting. You can take it. I want to weather forecast based on the previous data. वो वैसा डेटा रहेगा नहीं रहेगा, करप्शन रहेगी डेटा के अंदर, या whatever the data कितना पुराना है या और कितने पैरामीटर नए इंट्रोड्यूस हो रहे हैं, that is affecting our weather conditions, and then you should be able to give some model that can give you a fair solution that can be given to the people. Similar, this may be extended to avalanche prediction also. That is also a real life problem. There are various parameters that is contributing the environment itself, and how to predict that avalanche is going to happen at what time. Yeah. Okay. Okay.
Avalanche prediction.
Okay. That's a very realistic and very demanding application. Yeah, even landslides can also be. We can have that some kind of forecasting. And actually, forecasting is very important for us. You can handle that type of systems from designing can be very motivating and useful also after your research. It's not like this research nowadays is only on paper. But if it is application driven, then your research will definitely contribute to the society. So this is the domain where optimization can be applied, where we have very less knowledge about the system, but data is there. From that data, you can design your system that can work for you. I have only data, but can we have some kind of tool? I'll put that data that give me a fuzzy logic system. Ready-made fuzzy logic system, put it in a microprocessor or controller or some algorithm, and then solve your problem. From that data, I don't need to, being an engineer, I don't need to understand how ESO is working or GA is working. I don't need to understand, but I can have a tool like this that is done at the back end. All programming efforts has been done in programming itself. Now I just, मेरे को एक system design करना है, data है, put it that data, you will get your system. Put that system into hardware or some software, use it. That's the demand. Okay, I think your problem is addressed. Any other query relevant to this? We'll be coming with PSO. PSO, what is PSO? How much time we have? Hmm? 44. Okay. हाँ, वही इसीलिए थोड़ा सोच रहा था. Okay, bird flock. This is the program actually I have designed. Any query? Hello.
Hello.
Yes. Any query?
Hello.
Anchi.
So actually, I want to know that is it justified to use fuzzy logic systems if you need 100% accuracy?
Actually, fuzzy logic system. The objective of fuzzy logic system is to reduce computational time. If you want to increase the accuracy or the precision, then the purpose of fuzzy logic is going to be defeated. Isn't so? You make you design system, those give you an approximate solution. Otherwise, it will be very time consuming. Haji, are you listening?
Yes, sir. So actually, in the papers, I was seeing that people are trying to get the 100% success rate.
That is the research investigation can be done. Research investigation can be.
It is justified.
Paper accepted will justify. Paper accepted will justify.
See, I personally don't feel like it's 100% accuracy. Then why we are using fuzzy logic? We should use something else, isn't it?
Okay, I agree with your question. Most of the people are working towards their PhD work. They just want better results. They want even 0.1 improved results. मेरा भी यही attitude था जब मैं भी काम कर रहा था. Now at this stage of time, after doing that, now I understood that we should follow or design new approaches. Those give you a reasonably acceptable result in a limited time. If it is there, then your methodology is okay. Otherwise, you'll have to think in a different way. Paper acceptance is one very, important parameter during PhD work. तो उस व्यू पॉइंट से लोग रिसर्च करते हैं, इन्वेस्टिगेशंस करते हैं.
Thank you, sir. Thank you.
Okay. This is actually particle swarm optimization is copied from birds or fish school. They remain in group. In 1987, one simulation programmer, I won't say it is optimization programmer, कुछ ऐसा नहीं था. It was only simulation. Hollywood की picture के लिए एक bird flock को simulate किया गया था. And later on in 1995, the same concept was extended to optimization. That this can be copied into optimization as a optimization algorithm, and that is very first optimization algorithm that was based on mathematics. That's why it became very popular because of computational time was requirement was very less as compared to GA. At that time, GA 1975, GA came into, and in 1995, after 20 years, this has got a lot of popularity at that time because of this only, because it has all the calculation in mathematical formulas. Okay, that's why it is supposed to be one of the fastest algorithm. Now, whatever the new algorithms are coming up, they are taking more, hiring, you can say, borrowing some features of this algorithm in some other species, mimicking some other species. Okay. Population size leads to randomness. इसमें कुछ फीचर्स ऐसी हैं जो जैसे म्यूटेशन की रिक्वायरमेंट नहीं है. Whatever you do in your calculation will take care of mutation also. You will be just exploiting and exploring simultaneously. That's the advantage. One equation that will solve your problem. Okay, and this is what we have already discussed, that you can have fitness function. This is applicable in GA also and any other optimization algorithm. No problem. I think a lot of discussion has been done. Okay, bird flock, actually in bird flock they evaluate itself. They compare which other bird is having better location than me at present. Then try to mimic that. उसको imitate करने की कोशिश करते हैं जो better हैं. जैसे हम कहें कि क्लास के अंदर 10 लोग हैं, 50 लोग हैं, सॉरी, 50 लोगों में से एक टॉपर होता है नॉर्मली. We normally have one topper. तो वो हम लोग कहते हैं कि इससे सीखो कुछ. And objective is to have social learning. एक जैसे एक बंदा अच्छा परफॉर्म कर रहा है, उसकी जो जैसे वो चल रहा है, लोग उसको कॉपी करने की कोशिश करते हैं. It's a behavior of a bird flock also. कि bird flock का वैसे ओरिजिनल जो ऑब्जेक्टिव था, that was something different. कि bird flock इकट्ठा जो चलता है, उसके पीछे है कि अगर प्रेडेटर उसके ऊपर अटैक करता है तो सेंटर वाला जो है वो सेफ रहेगा. तो एवरीबॉडी विल ट्राई टू बी ऑन द सेंटर ताकि उसके ऊपर अटैक ना हो, वो बच जाएगा. तो दैट इज द ऑब्जेक्टिव. लेकिन यहाँ पे हमने उसको दूसरे तरीके से देखा कि हमने कहा कि भी हर एक जो पार्टिकल है, हियर वी कॉल इट पार्टिकल, दैट विल ट्राई टू कॉपी द बेस्ट वन. ओके, और there then some modification came into existence that is not actually relevant to any natural system, but it gave very good results. That's the variants of the PSO. Every algorithm has a lot of variants. जैसे GA के अंदर भी crossover के variants हैं, mutation के भी variants हैं, selection के भी variants हैं, and similarly here also there are a lot of variants. Variants are created intentionally. It's not inspired from natural system. Okay, तो जैसे हम कहेंगे कि बर्ड्स 10 लोग 50 लोग हैं तो 50 के 10 के 5 ग्रुप बना दिए, तो वो पहले 10 में आपस में कंपटीशन करें या एक दूसरे में उसमें से सीखने की कोशिश करें, तो 5 टॉपर्स बन गए। 5 टॉपर्स का मतलब अगर कहें कि वो उनमें से भी एक टॉपर होगा पूरी क्लास का ओवरऑल, तो वो भी एक लर्निंग अट्रैक्शन हो सकती है। तो देर में भी okay, so there may be multiple attractions for one person to learn from. Okay, one may be the local group leader, another may be the class holder leader, or multiply. If I say that my past is also there, I can learn from that also. For example, I was in the 8th class, I was the topper of the class. I am in the 12th class, now I am not the topper of the class. So what is the pattern that of studies that I followed in the 8th class can also be one of the parameter for me to reflect that. This is the way how do we learn. Present है क्लास के अंदर 2 लोग हैं, एक लीडर है, ग्रुप लीडर है, एक क्लास का टॉपर है, मेरा पास्ट है, तो I can combine them all also. Okay. Otherwise, जो original PSO algorithm था, that was something, there is only one topper in the class. That's it. And we'll be attracting toward that. मेरा past है साथ में. तो 2 पैरामीटर के साथ में हमने काम करते थे. Okay. So this is actually its own experiential knowledge and the knowledge of the individual and their performances. So, whatever the present scenario is there, who is performing better is also going to contribute towards my learning. Okay. Particles from will have to model this into some kind of mathematical, because it's a mathematics based algorithm. Will have to have some velocity that my learning so learning speed क्या है, कितना जल्दी मैं jump ले रहा हूँ, values को कितना change करूँगा. I'll be coming to parameter level also. Then fitness evaluation, similar to all other evolutionary algorithms, same is followed here also, and we'll try to find out the difference between the my present stage, toppers present stage, group leaders present state, my past best जो present है उनके बीच में कितना कितना difference आएगा, that will be my ring, and that will be used for then calculation of the new possible location, the new possible position of in next myself itself in the next iteration. Okay. This is the just I have talked to you about the working. This is cognitive learning exploration, that is from myself only, my past. Another is social learning from my neighborhoods, whoever are performing better, I'll be trying to mimic them. No, this is the mathematical formula. There are some algorithms that has given some changes into this formula and tried to make it somewhat acceptable to almost all application areas. Still, tuning is always required. There are some research investigation that is just conducted to tune its parameters so that it can be made suitable to most of the problem. But it's not a hard and fast rule that it has to be always these values. Depending upon your problem, it is to be tuned. Recently, we were working on one algorithm. It was node localization. There, the range of locations in an area, it is actually relevant to wireless sensor networks. I think some idea is with you. What is wireless sensor networks? How we do it? Okay. you have one idea. Okay, मैं थोड़ा सा आपको सिनेरियो क्लियर कर देता हूँ. It's a very popular area nowadays in the research. Let us say कि I want to deploy sensor nodes in a hill, and so that I want to forecast कि भाई मेरे पास अभी कहाँ पे कितनी स्नो है कौन सी हिल के ऊपर, और उसको मैं फोरकास्टिंग के लिए यूज करना चाहता हूँ वो डेटा को. वहाँ पे मेरे को लेकिन पहले पता तो चले कि कितना स्नो कहाँ पे हो चुकी है. बिफोर द स्नो आई विल डिप्लॉय माई सेंसर्स on the hill, and then I'll be collecting all that information at my what do you say, gateway. And now let's say I'm getting some information from one node. वो information मेरे लिए useless है अगर मेरे को उसकी location नहीं पता तो. अब आप कहो कि भाई मेरे को sensors deploy करने, तो deploy कैसे करते हैं? It's not done भाई वहाँ पे जाऊँगा वहाँ पे डालूंगा फिर उसके कोऑर्डिनेट्स नोट करूंगा. इट्स नॉट डन लाइक दिस. इट इज स्प्रेड, मतलब स्प्रिंकल्ड फ्रॉम द प्लेन एंड देन लेट इट फॉल वेयर एवर इट इज गोइंग, एंड देन वी गेट दैट इन्फॉर्मेशन. नाउ अब मेरे को उसकी लोकेशन के साथ में अगर इन्फॉर्मेशन मिलेगी देन इट विल बी ऑफ यूज फॉर मी. ऐसा नहीं है कि मतलब मैं यहाँ पे पास में पड़ा हुआ है उसकी इन्फॉर्मेशन मेरे को मिल रही है कि वहाँ पे कोई स्नो नहीं है, वेयर एवर इट इज ऑन द हिल टॉप. So if it is on the hilltop, then I must know that this is the sensor coming, information coming from hilltop. So location of the nodes is very important. Now आजकल तो थोड़ा GPS का भी mechanism है, लेकिन अगर आप GPS system हर एक node में लगाओगे तो that will give you that information, लेकिन it will cost more. To reduce that cost, we'll have to have some alternative way. तो वो जो लोकेशन आइडेंटिफिकेशन है उसके बीच में तो हमारे को सिग्नल स्ट्रेंथ से हम सिग्नल लोकेशन की डायरेक्शन और उसका लोकेशन थोड़ा सा आइडेंटिफाई कर सकते हैं. दिस इज अप्रॉक्सीमेट. एग्जैक्ट फिर वही बात है कि वी डोंट वांट एग्जैक्ट लोकेशन ऑफ द नोड, बट वी वांट अप्रॉक्सीमेट लोकेशन ऑफ द नोड, एंड दैट इज पॉसिबल विद द सिग्नल स्ट्रेंथ. You have one node over here and it is connected with another node, and whatever the signal strength is there in the environmental condition taking care of, you can identify. The same thing is possible. My cell phone can give me the location to the police department that this person is located at this place. This is all based on this concept only. कि sensor जो signal strength है आपके phone की, that can give you the location. Okay, that is the scenario. Now we had considered 100 by 100 units area जिसके अंदर हमने 50 sensors deploy कर दिए in simulation environment. Now the objective is to identify their locations. Now whatever the parameter we had into the PSO algorithm was not suitable to that scenario. Let us say I reduced that range to 10 by 10. Then it becomes another problem. I'll have to tune my parameters once again. Okay, so parameter tuning has to be done with respect to the signal strength and the area of your discussion and the range of every node radiation has to be taken care of, so that you can apply that problem. You can apply this algorithm in your problem. Okay, so this is one scenario that I just floated. A parameters क्या है? This is psi, CHI, normally chi बोल देते हैं, कोई कुछ कह देता है, and this is weight parameter जो velocity के साथ में है. Velocity is one parameter. Actually, if you see at this figure, this is the present location of my x parameter. Okay, means location means the value of that particular parameter. स्ट्रिंग लेंथ थी आपके पास, एक क्रोमोसोम जिसको हम कह रहे थे, अब यहाँ पे हम उसको पार्टिकल बोलेंगे. विल टॉक दैट दिस इज अ पार्टिकल, एंड वन पार्टिकल के अंदर का एक जो जीन जिसको कह रहे थे, जहाँ पे हम उसको एलिमेंट कह देते हैं, कि एक एलिमेंट की जो वैल्यू है वो एक्स एन है. एन इज कोरिस्पोंडिंग टू द आइट्रेशन नंबर. ओके, कि कौन सी आइट्रेशन है, आइट्रेशन अगली होगी तो फिर मेरे को अगली लोकेशन पे पहुंच जाऊंगा, लेकिन ये कैसे पहुंचना है, दिस इज द क्वेश्चन. ओके, नाउ दिस इज माय पास्ट बेस्ट, कि ये मैंने जब कभी अच्छा परफॉर्म कर रहा था तब मेरे पास ये वैल्यू थी उसकी, 2D दिखाया, सॉरी यहाँ पे मैं आपको 2D में दिखा रहा हूँ, अदरवाइज दिस इज 1D। एक ही पैरामीटर की वैल्यू की बात कर रहे हैं हम लोग। तो P बेस्ट जो थी वो ये वैल्यू थी, लेकिन अभी ये वैल्यू है, और जो ग्लोबल बेस्ट है मेरी क्लास में वो यहाँ पे है, उसकी वैल्यू ये है। और अगर मैं दोनों को कहूँगी भी दोनों का वेक्टर एडिशन कर लो, सिंपल है, वेक्टर एडिशन करता हूँ तो मेरे को ये लोकेशन मिलती है। ये मेरे पास पुरानी वेलोसिटी थी, अगर मैं इस डायरेक्शन में लर्निंग करता रहता तो इस डायरेक्शन में जाता, मैं इधर कहीं से आया था, ये मेरे पास पुरानी मतलब अभी प्रेजेंट वैल्यू है, मैं इधर से कहीं आया था, यहाँ पे हूँ, आगे इस साइड को जाने वाला हूँ, मैंने अपने लर्निंग में कोई चेंज नहीं कर रहा, आई एम नॉट मेकिंग एनी चेंज। तो जैसा हूँ मैं वैसा ही चलूंगा तो 65% नंबर आते हैं, तो आगे भी 65 ही आएंगे वैसे चलूंगा तो। क्लास के टॉपर के 95 आए, मेरे कभी 80 आए थे। तो अब मेरे को देखना है कि अब क्या करना है, नहीं चेंज करूंगा। देखिए मैं कहूंगा कि भाई आप कल से चेंज कर दो, कैन यू चेंज? इट्स नॉट दैट सिंपल, आई कैन नॉट, मतलब उसको ही हमने यहाँ पे मेक किया है इन द फॉर्म ऑफ वेलोसिटी, ये मेरी वेलोसिटी है, इस डायरेक्शन में मैं चल रहा हूँ। ओके, तो मैं दूसरे से भी कितना लर्न करूंगा, ये भी एक इशू है कि मेरा बिहेवियर है रैंडम, मैं दूसरों से कितना सीखता हूँ या मैं अपने से ज्यादा सीखता हूँ, अपने एक्सपीरियंस से ज्यादा सीखता हूँ, मेरा तो ऐसे ही तरीका, मैं तो ऐसे ही पढ़ूंगा, नो, इट इज वेरी सब्जेक्टिव, तो इट इज हैविंग लॉट ऑफ रैंडमनेस आल्सो। तो एक रैंडम नंबर के साथ में आप इस डिफरेंस को मल्टीप्लाई करोगे, इसका और इसका डिफरेंस निकाला, और इसके साथ में एक रैंडम नंबर को डिफरेंस को मल्टीप्लाई कर दिया, दिस इज व्हाट इज नाउ, दिस इज द पास्ट बेस्ट, दिस इज द प्रेजेंट, दोनों का डिफरेंस निकाला, एक रैंडम नंबर के साथ में मल्टीप्लाई कर दिया, दिस इज आर इज रैंडम नंबर। सबस्क्रिप्ट और सुपरस्क्रिप्ट को अभी थोड़ी देर के लिए छोड़ दो, इट्स अ रैंडम नंबर। सबस्क्रिप्ट जो है दैट इज जस्ट द n इज द आइटरेशन नंबर, सबस्क्रिप्ट जो है दैट इज द रैंडम नंबर 1, रैंडम नंबर 2, ठीक है, और कुछ नहीं है, दोनों को अलग अलग किया है, दोनों एक ही नंबर नहीं है। और ये वर्फी है, एक और पैरामीटर साथ में मल्टीप्लाई कर दिया, ट्यूनिंग पैरामीटर, स्ट्रेटेजी पैरामीटर, दैट इज टू बी ट्यून्ड विद रिस्पेक्ट टू द एप्लीकेशन। रैंडम नंबर होगा 0 से 1 के बीच में, आपके पास डिफरेंस की कितनी वैल्यू होगी, दैट इज टू बी ट्यून्ड विद रिस्पेक्ट टू कि जंप ऐसा बड़ा ना हो जाए कि सर्च स्पेस से बाहर निकल जाए, ठीक है। तो दैट इज वन ट्यूनिंग पैरामीटर कि आपको जो एप्लीकेशन के रेलेवेंट में लेकर चलना है। नाउ सिमिलर टू द ग्लोबल बेस्ट, ग्लोबल बेस्ट PGD डायमेंशन, डी ये डायमेंशन के साथ में है, डी सभी में सबस्क्रिप्ट में आ रहा है कि पहले वाला एलिमेंट या दूसरे वाला एलिमेंट, पार्टिकल का कौन सा एलिमेंट, ये सारे एलिमेंट्स के साथ में यही काम करना है ताकि नई लोकेशन सबकी मिल जाए। ओके, थोड़ा सा अगर मैं सी प्रोग्रामिंग के व्यू पॉइंट से सोचूं, आई थिंक इट इज बिट complicated. If you talk about MATLAB, it is going to be matrix manipulation only. In one shot, you can generate n numbers and multiply with one matrix, and then you'll be getting with addition another matrix. Okay, it is simple in case of MATLAB. Okay, this is the new velocity. This is the present location. At that velocity, you'll be getting the new location. Now, you can suppose इसमें exploitation और exploration दोनों ही इकट्ठी हो रही हैं। ये मेरे पास पुरानी वैल्यू थी, इन दोनों को कॉम्बिनेशन नहीं किया हमने, इनमें से किसी को यूज नहीं कर रहे, दोनों को मिक्स करके यूज कर रहे हैं। तो एक्सप्लोरेशन भी साथ साथ हो रही है, एक्सप्लॉयटेशन भी हो रही है। एक्सप्लॉयटेशन मींस कि एग्जिस्टिंग वैल्यूज को यूज करना, ओके, एंड एक्सप्लॉयटेशन सॉरी एक्सप्लोरेशन की नई लोकेशन के ऊपर पहुंचना जो पहले मेरे पास दोनों में नहीं थी, ठीक है। दिस इज द कॉन्सेप्ट। ये एक पैरामीटर, एक पार्टिकल के अंदर से फर्स्ट एलिमेंट, देन सेकंड एलिमेंट, थर्ड एलिमेंट, 6 पैरामीटर हैं, एक स्ट्रिंग पूरी हो जाती है। दिस इज टू बी डन ऑल 6 टाइम्स, देन यू विल बी गेटिंग न्यू पार्टिकल लोकेशन। एक पार्टिकल के अंदर, अब एक पार्टिकल के अंदर ये भी एक इंपॉर्टेंट है कि भी ये जी कौन सा होगा। मल्टीपल पार्टिकल्स के अंदर यू विल बी हैविंग multiple past best, you'll have to keep record of that. P best is every particles having past best. If 6, 7, let's say 6 particles are there, then there will be 6 P best, 1 G best, that will be common to all. Then X1, X2, X3 relevant to every parameter of the swarm. Okay. Now this is to be coded in the form of algorithm. Okay. Any query till this time? Both are giving equivalent. Most of the research paper has given all of those came after GA during PSO. They have obviously proved that the PSO is better. Otherwise, GA is having one very significant advantage. In GA, every solution is applicable solution. You can make use of that. Now, what will happen in this case? Let us say there is 1 G best and that has reached almost the maximum. After some time, everybody will be coming to that point. ऐसे ही होगा ना कि कॉपी करते करते आएंगे, थोड़ा टाइम लग जाएगा रैंडम नंबर की वजह से, लेकिन पहुंचेंगे एक जगह पे ही. You will be ultimately whole swarm will contribute only one solution. लेकिन GA after 100 iteration या 1000 iteration every solution is applicable solution. आपको पहला पसंद नहीं है, छोड़ दो, दूसरे को ले लो. That is the biggest advantage. In case of multi-objective problem, we take full advantage of that. We get multiple solutions at the end in GA, and every solution is applicable. आपने कोई पैरामीटर का ध्यान नहीं रखा during your design, but once you get your solution, you found that L1 is the best solution is that is not suitable. Now what to do? Redo the same. Leave one. Talk about second. क्या वो आपकी वो प्रॉब्लम को हैंडल कर लेता है? अगर कर लेता है तो you can use it. But in case of PSO, everybody will be coming to one point. That's the limitation. You will be getting only one solution at the end of the all iterations. Okay. तो जिस कारण मतलब अभी भी GA को एक अच्छा कॉम्पिटिटर माना जाता है, although it is quite old now, 75 आज 40 years होने हो गए हैं. तो it's a quite effective till date. Okay, let's move to some variants of this. This is local best. यहाँ पे हम लोग ग्लोबल बेस्ट की बात नहीं करते, कि पूरी क्लास में टॉपर की बात नहीं कर रहे. एक स्मॉल वेरिएंट क्या किया कि पूरी पॉपुलेशन को 10 में 10-10 के ग्रुप बना दिए. जैसे 50 की पूरी क्लास थी तो उसके 10-10 के ग्रुप बना दिए. उसमें कोई क्लास का टॉपर नहीं है, हर एक का अपने एक ग्रुप टॉपर है. अब इसका एडवांटेज क्या होगा? क्यों ऐसा इंट्रोड्यूस किया गया? इट विल हैव अ लोकल सर्च. पहले क्या था कि क्लास में एक टॉपर था, सारे उसकी तरफ जा रहे थे. अब वो जो टॉपर था वो एक लोकल मिनिमा पे बैठा था या लोकल ऑप्टिमा के बैठा था, तो सारे उसके पास पहुंचने की कोशिश कर रहे थे. क्या होगा? मोस्ट प्रोबेबली यू विल बी मिसिंग द मैक्सिमा. इसको बोलते हैं लोकल ट्रैप. योर एल्गोरिथम विल बी ट्रैप्ड इन अ लोकल ऑप्टिमा. That is the limitation of the PSO. To overcome that limitation, another model was proposed where the whole swarm is divided into groups and every group will have one leader. At the end of this all, actually this is not now one PSO, it's actually small 5 PSOs जो अपने स्वाम के अंदर ही बात करते हैं. वो आपकी पूरी सर्च स्पेस को कवर कर रहे हैं. That is the advantage. At the end, you'll have 5 solutions. Anyone can be suitable. Obviously, at the end, we'll be comparing that which one is the best.
Will it move faster?
No, it will be definitely slower.
Slow?
Yeah. It is divided into multiple segments. It is going to be slow, but it will give you an advantage of local optima में trap नहीं होगा. Okay, are you getting the फिलॉसफी? समझ लीजिए, एल्गोरिथम में थोड़ा सा आ जाएगा, फिर उसकी प्रोग्रामिंग के ऊपर चलते हैं. ओके, शुड आई मूव अहेड? हाँ, ऑब्वियसली था ये भी तो हो सकता था ना कि भी ग्लोबल बेस्ट भी है, फास्ट बेस्ट भी है और लोकल बेस्ट भी है। तो ये मैंने छोटी सी मॉडिफिकेशन प्रपोज करी थी एंड इसके ऊपर बाद में पेपर काफ़ी निकले लोगों के कि छोटा सा चेंज कि कॉमन सेंस है, थोड़ा सा काम टाइम जरूर लग रहा है, तो फिर इसके ऊपर इन्वेस्टिगेशन करी थी तो दैट रिजल्टेड इन मतलब कि भाई इसके कंप्यूटेशनल टाइम ज़्यादा था। अगर आप कंप्यूटेशन टाइम किसी और तरीके से कम कर लो तो विद लेस नंबर ऑफ आइट्रेशन यू कैन अचीव योर टारगेट। इसमें जो रिजल्ट्स हैं वो जल्दी कन्वर्ट कर देते हैं। नाउ हियर वी आर हैविंग 4 अट्रैक्शंस। वन इज पी बेस्ट, फास्ट बेस्ट, ग्लोबल बेस्ट, local best, velocity, and then final. Everything is being multiplied with some random number. ये ट्यूनिंग पैरामीटर है जी, इनकी वैल्यूज हैं कुछ स्पेसिफिक, मतलब जो मैंने भी यूज़ करी थी। कुछ रिसर्चर ने इसी के ऊपर, मतलब जो इन्वेंटर था इसने इंट्रोड्यूस किया था, एवरहार्ट ने जो प्रपोज किया था पीएसओ को, तो उन्होंने कुछ इसी के ऊपर इन्वेस्टिगेशन करी थी कि इसके जो स्ट्रेटजी पैरामीटर दैट हैज़ टू बी ट्यूनिंग, दैट हैज़ टू बी ट्यून्ड। तो वो ट्यूनिंग कैसे कर सकते हैं और पैरामीटर्स क्या दिए थे वो इस फिक्स हैं, वो आप यूज़ कर सकते हो अगर आपने सिर्फ अपनी एप्लीकेशन के ऊपर कॉन्सेंट्रेट करना है। अदरवाइज फॉर योर एप्लीकेशन इट इज़ टू बी ट्यून्ड अगेन, ओके, ताकि और बेटर रिजल्ट मिल सके। ओके, नाउ मोर वेरिएंट्स आर देयर इनटू दिस। एक जो लोकल बेस्ट वाला कॉन्सेप्ट आ गया, इसमें बहुत सारी टोपोलॉजीज के आ गई। एक तो फुल्ली कनेक्टेड है जिसको पीएसओ बोलते हैं। एक है रिंग टोपोलॉजी, ये रिंग की फॉर्मेट में है, आई शो दैट। दिस इज फुल्ली कनेक्टेड पीएसओ, जो ग्लोबल बेस्ट पीएसओ मॉडल हम नाम इसको देते हैं, जी बेस्ट मॉडल है। तो जिसमें ग्लोबल बेस्ट के साथ में मतलब सबको पता है कि कौन ग्लोबल बेस्ट है, पूरी क्लास को पता है कि कौन टॉपर है, ठीक है। The another is ring topology. ये 3 का एक ग्रुप है। इसको सिर्फ ये पता है या तो ये टॉपर है या ये टॉपर है या मैं टॉपर हूं। इसको ये नहीं पता कि 6th वाला भी टॉपर है ओवरऑल या नहीं है। ये तीनों में से तो इनको पता है कौन टॉपर है इसको, लेकिन इनका और इनका पता है, इसको इसका और इसका पता है। तो इट्स अ रिंग टाइप। इसको एक साइड से ओपन कर दो तो लीनियर हो गया। ये भी एक एक्सपेरिमेंट किया था और उसमें रिजल्ट नहीं मिले, तो लोगों ने एक्सपेरिमेंट करके छोड़ दिया। फिर क्या है कि एक के साथ में सारे कनेक्टेड हों, दैट इज व्हील टोपोलॉजी। अगर आप व्हील अभी लग नहीं रहा, आप इसको सेंटर में ले आओ, व्हील लग जाएगा कि वन इज नोन टू एवरीबॉडी, मतलब एक सबके बारे में जानता है। तो व्हील टोपोलॉजी एक्सपेरिमेंट करने में किया जाता है, रिसर्च कई लोग ऐसे भी करते हैं। हो सकता है इसमें कुछ रिजल्ट आ जाए, लेकिन ऑब्वियस है आप हम लोग इसको एक्सपेक्ट कर सकते हैं कि इट्स नॉट गोइंग टू दैट, जी बेस्ट इज गोइंग टू बी मच बेटर इन दिस केस। बट अगर ये रिंग टोपोलॉजी, लीनियर टोपोलॉजी है, तो इसके साथ में एक्सपेरिमेंट्स किए गए। ये फार्मूलाज के बारे में मैं चलो प्रोग्रामिंग में ले चलता हूँ इसको। ये पैरामीटर्स की जो बात थी मैंने आपको बीच में थोड़ा बता दिया है। सूडो कोड है, आई थिंक विल कम टू दैट। ओके, अब बीच में क्वेश्चन आया था, मैंने उस टाइम पे थोड़ा पॉज दे दिया था, ज़्यादा डिटेल में नहीं लेके गया था कि भाई हम कैसे चेक करते हैं कि मेरा एल्गोरिथम बढ़िया है या नहीं बढ़िया। हाउ टू चेक? तो देयर आर सम बेंचमार्क फंक्शंस। दिस इज जस्ट शोन इन 3D, अदरवाइज ये 3D हम नहीं रखते। फॉर्मूला आप समझ लीजिए कि n इज इक्वल टू 1 to 2, n की वैल्यू अगर 2 है तो x1 स्क्वायर प्लस x2 स्क्वायर। अगर ये एक्सिस x1 है, ये x2 है, तो ये ऐसा दिखेगा। तो अगर सिर्फ x1 होता तो ये पैराबोला था, सिंपल है। अगर मैं कहूँ n की वैल्यू 3 है तो शायद विजुलाइज करना मुश्किल है, लेकिन 3D में प्लॉट करना मुश्किल है, लेकिन विजुलाइज कर सकते हैं आई थिंक, isn't so? कि x1 स्क्वायर प्लस x2 स्क्वायर प्लस x3 स्क्वायर, मे बी n मे बी गोइंग टू 10 और 20। समझ आ रहा है कि मिनिमम उसका क्या होगा? 0। x1 की वैल्यू 0, x2 की वैल्यू 0, x3 की वैल्यू 0, पुट एवरीथिंग एज 0, यू विल बी हैविंग मिनिमा। उससे नीचे तो नहीं आ सकते ना। माइनस की वैल्यू डालोगे, x की वैल्यू पॉजिटिव हो जाएगी, स्क्वायर हो जाएगा। So I think we can understand there is only one minima, and that is at अब इसकी सिंपलिसिटी है कि दिस फंक्शन is having only one minima and there is no local optima. Okay, it's a bowl type. There is no other दूसरी कोई peak या minima नहीं है. It's only one minima, and there is there is one simple mathematics also. Even your calculus method can also solve this problem. Our objective is not to solve this problem. Our objective is to tackle this problem using algorithm. कि मैंने तो कहा कि भी लर्निंग होती है और मैंने एक पार्टिकल को यहाँ पे डाल दिया, एक को यहाँ डाल दिया, सबको अलग अलग लोकेशन पे डाल देता हूं, तो वो एक दूसरे से लर्न करते हुए पहुंचे नीचे तक. ठीक है, तो एल्गोरिथम क्या है, इसको सॉल्व कर लेगा. जो फिलॉसफी, whatever the philosophy we have planned in PSO or GA, is that applicable and giving me a solution in this problem? That is what is the objective here. I know what is the resultant of this. This is not my target कि मैं इसको ही solve करना है. This is not, but this is definitely giving me कि भी मेरा जो algorithm वो run कर रहा है वो सही result दे रहा है या नहीं दे रहा है. Until unless I do not know, because there are a lot of use of random numbers. It is called stochastic search algorithm. There is a lot of every iteration में आपको नए results मिलेंगे. We are not going to get same results just like simple mathematics. In calculus methods अगर आप follow करोगे, you will be getting same results every time. But यहाँ पे नहीं मिलेगा आपको. आप 100 iteration करोगे, दूसरी बार ही 100 iteration करोगे, you will be getting different answers. तो हम इसको फिर मल्टीपल टाइम्स रन करते हैं. दैट इज रन इट 20 टाइम्स, फिर उसकी एवरेज को देखते हैं कि एवरेज परफॉर्मेंस क्या जा रही है. दिस इज कॉल्ड मॉन्टे कार्लो सिमुलेशंस ऑफ द सेम प्रॉब्लम सॉल्यूशन. देन वी एवरेज देम ऑल. आई विल शो दैट. दिस इज अनदर फंक्शन रोजनब्रॉक. मैथमेटिकल फॉर्मूले साथ में दिए हैं. It's all available on internet also. A lot of material is available. Every algorithm have you made use of these functions for testing their algorithm performance. Okay, so this is the shape. Actually this is zoomed out, this is zoomed in. Actually there is only one minima, that is at 0 0 0. When x is 0, all zeros, you will be getting the value. Okay, this is the another ACLE function. It's having multiple. Actually ये zoom करके function एक ही है, एक में zoom out है, एक में zoom in किया हुआ. थोड़ा सा range को आप देख लीजिए. तो अगर अंदर हम देखते हैं उसके, you will be having multiple minimas, no, and but there is global minima is only one, that is at the center. Okay, तो ये अब इसके अंदर पहला वाला सिंपल था. सिंपल को अगर हम नहीं सॉल्व कर सकते तो कॉम्प्लिकेटेड को नहीं सॉल्व कर सकते, तो थोड़ा सा आइडिया लग जाएगा कि मेरी प्रॉब्लम कितनी है, वो कैसी कॉम्प्लिकेटेड है. उसके अंदर मल्टीपल सॉल्यूशंस पॉसिबल हैं, एंड मल्टीपल सॉल्यूशन कैन हैव मल्टीपल मिनिमास आल्सो. ऐसा ना हो कि मैं लोकल मिनिमा के अंदर ट्रैप हो करके रह जाऊं. माय प्रॉब्लम विल बी नॉट सॉल्व्ड इन दैट केस. देन मोर functions, there are many multiple optimas, maximas and minimas. You can use this this function for identifying global maxima or minima. Okay, even you can specify some constraint. I don't want to go into the center, a bit away from the center, whatever the maxima or minima is there, I want to identify that. Even that is possible. So whatever the mathematics formula, it's all formula driven, it's not data driven. Okay, ग्रीवांग फंक्शन, ये यहाँ पे मैं आपको सिर्फ x1 x2 के लिए दिखा रहा हूँ. एवरी फंक्शन इज स्केलेबल. ओके, स्केलेबल मतलब डायमेंशंस कैन बी इंक्रीज, n कैन बी इंक्रीज टू 10 20, नॉट इशू. लेकिन अगर आप उसको विजुलाइज करना चाहेंगे तो सिर्फ 2 पैरामीटर को मान करके आप इसको विजुलाइज कर सकते हैं. दिस इज अनदर वन. शेफर फंक्शन। वैसे तो लिस्ट तो बहुत लंबी है, आई थिंक मैंने 6-7 के रखे थे, थोड़ा सा आइडिया लग जाता है। अब मैंने जीए के साथ में काम करना, देखो वो कैसे लोगों ने प्रूव किया था कि भाई जीए के साथ में मेरे रिजल्ट अच्छे आए। पीएसओ कहेगा नहीं, जब पीएसओ वाला कहेगा तो नहीं मेरे रिजल्ट जीए से बेटर आए। कैसे करते हैं कि भाई अब आपके पास रिजल्ट दोनों में तकरीबन सिमिलर से होते हैं, बहुत प्रोसीजर में कम मतलब डिफरेंस रहता है। वी मेक अनदर व्यू पॉइंट, जी कैलकुलेशन में टाइम कम लगा, दैट इज वन वे टू प्रेजेंट योर एल्गोरिथम कि भाई आपने रिजल्ट ऑलमोस्ट सिमिलर आ गए लेकिन कैलकुलेशन टाइम कम लगा। या आप कुछ और पैरामीटर की बात कर रहे हो कि भाई ये जो एल्गोरिथम है ये इस तरह की प्रॉब्लम के ऊपर तो अच्छा परफॉर्म करता है, और फिर उसकी एक रियल लाइफ प्रॉब्लम ले ली कि भाई ये उसके साथ में रेलेवेंट एक रियल लाइफ प्रॉब्लम है जिसके ऊपर पीएसओ बेटर परफॉर्म करता है जीए से, मेरे को तो एक ही सोल्यूशन चाहिए। अगर जीए को अच्छा दिखाना है, नहीं, यू कैन हैव अ प्रॉब्लम लाइक दिस जिसमें आपको मल्टीपल सोल्यूशन चाहिए, तो एक को डिस्कार्ड किया दूसरे को यूज कर लिया। कैलकुलेशन टाइम इज नॉट सिग्निफिकेंट, भाई मेरे लिए ऑफलाइन सोल्यूशन है तो इट्स नॉट दैट इंपॉर्टेंट। अब मेरे को ऑनलाइन सोल्यूशन चाहिए, जैसे एक बीच में प्रॉब्लम ऑडियंस ने किसी ने पॉइंट आउट की थी कि भाई मेरे पास रियल टाइम ऑप्टिमाइजेशन करनी है, देन कैलकुलेशन टाइम बिकम्स वेरी सिग्निफिकेंट। So you'll have to take care of that. This application is very much suitable for PSO algorithm. Okay, so you will have to understand the nature of the algorithm and your problem, then try to find out the compromise between the two. It's not always there that एक साथ में और important parameters है parameter tuning. You'll have to tune your parameters also with respect to your demand of the algorithm. भी आपको demand क्या है? Okay. Scenario, whatever the scenario that you'll have to take care of. Okay, so these are the parameters you'll have to take care. और ये जो एल्गोरिथम जिसकी मैं बात कर रहा था कि मैंने ड्यूरिंग रिसर्च डिजाइन, तो उसमें यूजर इंटरफेस पहले तो मैंने प्रोग्रामिंग के साथ में कर रहा था, अभी रिसर्च में है। यू कैन अंडरस्टैंड कि भी अगर मैंने एक प्रॉब्लम को सॉल्व किया, अगर उसका एक प्रॉब्लम फॉर्मूला बना लिया या मैंने एक छोटा कोड बना लिया, थोड़ी देर के बाद पता चला कि नहीं चेंज हो गया। मैंने एक फजी सिस्टम को इवैल्यूएट करना था, मैंने बनाया और उसको लेट्स से 3 फजी सेट के साथ में बनाया था, नहीं अब 4 बनाने हैं, रूल भी चेंज, फजी सेट भी चेंज, इम्प्लीकेशन, एग्रीगेशन, डीफजिफिकेशन, एवरीथिंग विल बी इफेक्टेड विद दैट। नाउ रीराइटिंग द कोड, क्योंकि हो सकता है वापस भी आना पड़े, इट्स नॉट नेसेसरी दैट यू विल बी गेटिंग मतलब 4 के साथ में आपको अच्छा रिजल्ट मिल जाएगा। यू आर एक्सपेरिमेंटिंग विद अ सिमिलर ऑब्जेक्टिव। आफ्टर डिजाइनिंग 1-2 एल्गोरिथम आई फाइंड दैट ये तो बहुत प्रॉब्लम होगी, आई विल बी डूइंग अगेन एंड अगेन, कोडिंग इज टू बी डन अगेन एंड अगेन। देन आई डिजाइन वन टूल एंड द टूल इज मेड लाइक दिस, you specify your parameters in the form of user interface. And another important parameter is Excel interface. I specified my all the parameters in Excel. If this is the range of the universal discourse for parameters, and it will pick up that Excel sheet, pick up your fitness function, then solve it, iterate it. स्ट्रेटेजी पैरामीटर यू कैन गिव इट थ्रू, जैसे C1 है कॉग्निटिव लर्निंग, तो सेल्फ लर्निंग P बेस्ट के साथ में जो एक पैरामीटर वॉर्फी 1 आया था। ये है सोशल लर्निंग कि जो मेरे पास ग्लोबल बेस्ट से है, नेबरहुड L1 के साथ में जो पैरामीटर मल्टीप्लाई हुआ, रैंडम नंबर तो हो गई रहे, वेलोसिटी क्या है, जो ओवरऑल मल्टीप्लाइंग फैक्टर क्या है, वेट क्या है, ये कुछ पैरामीटर स्ट्रेटेजी पैरामीटर्स हैं जिनका यूज कर सकते हैं। टर्मिनेशन क्राइटेरिया क्या लगाना चाहते हैं, ट्रेनिंग डेटा अगर है तो आप यूज कर सकते हो। तो ट्रेनिंग डेटा आपका क्या है, अगर आप ट्रेनिंग डेटा से निकालना चाहते हो अपने सिस्टम को, तो दैट इज ऑल पॉसिबल। अब ये जो एक्सेल की जो शीट है, दिस एक्चुअली कंटेन्स लिस्ट ऑफ पैरामीटर। अब ये पैरामीटर आपके फजी सिस्टम भी हो सकता है, आई विल शो दैट एग्जांपल। एक्सेल की एक फाइल आपको दिखा देता हूँ। और मॉडल जैसे H बेस्ट है, हाइब्रिड बेस्ट है, G बेस्ट एक था, एक L बेस्ट था, ये हाइब्रिड बेस्ट था, दोनों को मतलब मिक्स कर दिया। और वैलिडेशन लगानी पड़ती थी कि ऐसा तो नहीं कि सर्च स्पेस से बाहर निकल जाए मेरा, तो दैट इज ऑल्सो रिक्वायर्ड समटाइम्स कि भाई ऐसा ना हो कि आप सर्च तो कर रहे हो लेकिन अपनी सर्च स्पेस से बाहर जाकर के सर्च करो, इट्स ऑल यूजलेस इन दैट केस। यू विल हैव टू हैव सम वैलिडेशन फंक्शन। टोपोलॉजीज कौन सी फॉलो करना चाहते हो जो, तो ये जीए का पहले तो एल्गोरिथम बनाया, देन उसका फिर डिज़ाइन बनाया कि भी मेरा का ये कोड बनता है, फिर उसमें से देखा कि कौन कौन से स्ट्रेटेजी पैरामीटर है जो मेरे पास चेंज हो सकते हैं और उनको बाहर निकाल लिया, उसको यूजर इंटरफेस में दे दिया या एक्सेल में डाल दिया। नाउ दिस एल्गोरिथम कैन बी यूज्ड एन नंबर ऑफ टाइम्स एंड यू कैन ऑप्टिमाइज एनी सिस्टम। This is fitness function. No, sorry, actually, objective function. Actually,
that in MATLAB became we have just called it.
Just name that. It will pick up that. I'll show that demonstration में भी आएगा। तो इसके अंदर प्लॉट्स वगैरह हैं कि आप एवरेज प्लॉट और जो बेस्ट हैं, जो फिटनेस बेस्ट सोल्यूशन की है, देखिए एक तो बेस्ट होगा, बाकी धीरे धीरे जाकर के सारे इकट्ठे हो जाएंगे एक जगह पे, जो कोलिजन वाला काम है। फाइनली अगर मैं कहता हूँ इसको 10,000 आइट्रेशन के लिए या 20,000 आइट्रेशन के लिए चलाता हूँ, देन आई विल बी गेटिंग ऑल सोल्यूशन एट वन लोकेशन, मींस ओनली वन सोल्यूशन इज देयर। आई शो दैट। ये जो पहले काम था ना, ये मेरे को नहीं पहले दिख रहा था, आई वाज वेटिंग एंड वेटिंग, जस्ट एक छोटी सी बिजी हो गया एंड दैट्स व्हाट आई विल नॉट बी एबल टू, देन आई पुट दैट इंफॉर्मेशन ओवर देयर इन द यूजर इंटरफेस, कितना टाइम अभी हो चुका है और कितनी आइट्रेशन लगाई हैं, कितनी कंप्लीट हो गई हैं, कितनी फिटनेस वैल्यू आ रही है, कितनी एवरेज फिटनेस आ रही है। अगर मैं पॉज भी करना चाहूँ तो पॉज कर सकता हूँ और रीस्टार्ट कर सकता हूँ या रिज्यूम कर सकता हूँ। ये फीचर्स बाद में डाली थी क्योंकि मेरे को लग रहा था कि 6 दिन बैठना और पता चले कि रिजल्ट नहीं आ रहा है, फिर साथ साथ प्लॉट करने वाला काम, ये थोड़ा सा मेरे को लगा कि भाई इट इज़ रिक्वायर्ड, यू शुड बी मतलब मोटिवेटिव एट दैट टाइम, अदरवाइज थोड़ी देर के बाद में हाइपर होना शुरू हो जाता है बंदा पता नहीं क्या हो रहा है। तो दैट्स द जस्ट रिक्वायरमेंट दैट आई फेल्ट। ओके, आई विल टेक दैट डेमोंस्ट्रेशन नाउ। ये मैटलैब के पुराने वर्जन में मैंने बनाया था, स्टिल विद सम माइनर वार्निंग, इट्स वर्किंग। ओके, there are many files. मैंने इससे पहले एक जनरलाइज फाइल सिस्टम का एक टूल बॉक्स बनाया था, दैट इज वेरी यू से दैट इट्स नॉट दैट प्रोफेशनली डिजाइंड। मेरे को उसको बनाते बनाते मेरे को कमियां समझ आई, देन आई हैड टेकन केयर ऑफ दैट। मैं अगर आपको उसको यहाँ से बताना शुरू करूँ तो कुछ फाइल्स हैं जो आपको बता सकता हूँ डिटेल में। जैसे एक तो NI टूल है, NI टूल के अंदर यूजर इंटरफेस है, यहाँ पे आपका यूजर इंटरफेस मिलेगा आपको। सिस्टम थोड़ा स्लो चल रहा है, मतलब दिस इज कनेक्टेड टू मेनी अदर, दैट्स व्हाई। ओके, ओके, दिस इज द इंटरफेस जो आपको मिलेगा। इसके अंदर आप नई फाइल क्रिएट कर सकते हो, यू कैन क्रिएट, यू कैन अटैच एक्सेल की फाइल एक अलग से बना करके इसी फोल्डर के अंदर रख करके यू कैन लिंक विद दैट, जस्ट गिव द नेम शीट एंड द रेंज ऑफ वैल्यूज कि कहाँ से लेकर के कहाँ तक आप कॉपी करना चाहते हो एंड कौन सा मॉडल। अगर आप एल बेस्ट यूज़ करोगे तो आपको ये ऑप्शन मिलेंगी, अगर जी बेस्ट है तो ये ऑप्शन उसमें नहीं आती। ओके, तो ट्रेनिंग डेटा आपका कहाँ पे पड़ा हुआ है, फिटनेस फंक्शन का नाम क्या है, ये डिफ़ॉल्ट वैल्यूज हैं, आप चेंज करना चाहो चेंज कर सकते हो, इट इज़ पॉसिबल। वेट के अंदर भी एक्सपेरिमेंटेशन करी गई है, तो मैंने इसको भी पैरामीटर एज ए कंसिडर किए हैं। यू कैन मेक वेरिएशन इन दिस केस आल्सो, अदरवाइज मोस्ट ऑफ द टाइम वी मेक इट फ्रोजन, और इट कैन आल्सो बी मेड लाइक दिस दैट it will increase or decrease with the number of iteration. एक्सपेरिमेंटेशन है, एक्सप्लोरेशन को बढ़ाना है या कम करना है विद द नंबर ऑफ आइट्रेशन, दैट कैन बी रिलेटेड टू दिस। और ये प्लॉट करने के लिए आइट्रेशन को कितने आइट्रेशन रन करनी है, कितना टर्मिनेट करना चाहते हैं। ओके, मैं किसी एग्जिस्टिंग को उठा लेता हूँ। आई कैन जस्ट ओपन, बहुत सारे मतलब PSO डॉट एक्सटेंशन मैंने स्पेशली इसी काम के लिए रखी थी कि PSO एक्सटेंशन मीन्स कि जिसके अंदर असल में बैकएंड पे एक टेक्स्ट फाइल है, उसको नाम डॉट PSO दे दिया है और उस फाइल को उठा करके आप यूज़ कर सकते हैं। लेट्स से आई विल टेक वन एग्जांपल। ओके, दिस इज द इनकोडिंग XLS। तो मैं इनकोडिंग XLS एक फाइल होगी यहाँ पे, मैं इसको आउटसाइड मैटलैब आपको प्लॉट करके रन करके दिखा देता हूँ क्या है इसके अंदर। यहाँ पे मेरे पास स्ट्रिंग के पैरामीटर्स हैं। आई थिंक यू कैन रिलेट विद योर प्रॉब्लम, whatever your domain area is, there you will be having some parameters in their respective universe or discourse. Still running? Okay. How much time we are left with? Okay. Okay, I'll try to rush through this. Okay, these are the constraints, मैं चेक लगाए हुए हैं। ये अदरवाइज पैरामीटर्स हैं कि आपकी मिनिमम वैल्यू क्या है, मैक्सिमम वैल्यू क्या है, रेजोल्यूशन कितनी है उसके अंदर। ये फजी सेट्स की एवोल्यूशन के लिए बनाया था। रन करूंगा, टाइम कंज्यूमिंग जरूर है। ये फजी लॉजिक जो फजी सेट्स हैं उसकी जो फर्स्ट पॉइंट है, सेकंड पॉइंट, सेकंड फर्स्ट फजी सेट का फर्स्ट पॉइंट, सेकंड पॉइंट, सेकंड फजी सेट का फर्स्ट पॉइंट, सेकंड सेट। तो कितने मेरे पास चार फजी सेट्स हैं। एक इनपुट के लिए 4 फजी सेट है, दूसरे इनपुट के लिए 4 फजी सेट्स हैं। तो टोटल स्ट्रिंग लेंथ जो आपको मैंने फॉर्मूला से बताई थी, दिस इज रूल बेस्ड कि -4 से लेकर के 4 इंटीजर वैल्यूज हो सकती हैं एंड कितने रूल्स हैं कॉरेस्पॉन्डिंग टू दैट यू विल हैव स्ट्रिंग लेंथ। तो अब इसको इवॉल्व करना है। बैकएंड पे इसके जो फंक्शन है, ये जो बैकएंड पे ऑब्जेक्टिव फंक्शन है, यहाँ पे अकेले की बात नहीं है, यहाँ किसी और की नहीं है, ऑब्जेक्टिव फंक्शन है जिसमें फजी सिस्टम बनाया गया है। वो फजी सिस्टम को इनपुट देते हैं, वो आउटपुट देगा। वो उसको 500 इनपुट दी जाएंगी डेटाबेस से उठा करके, दूसरी फाइल से। ये दूसरी फाइल है ट्रेनिंग डेटा, यहाँ से इनपुट उठा करके उसको दी और फिर उसने फिटनेस फंक्शन को डेटा भी दिया, फजी सिस्टम भी दिया, स्ट्रिंग एक बना करके फिर उसको इवेलुएट किया। उसकी जो फिटनेस निकाली वो रिकॉर्ड करेगी। ओके, तो दिस इज दी वे। मैं आपको एक छोटा एल्गोरिथम रन करके दिखा देता हूँ। ओके, लेट्स से डिजोंग जो स्फीयर टाइप का है, छोटा सा है और इसमें रिस्पांस भी इजीली दिख जाएगा आपको। यहाँ पे डेटा पॉइंट की वैल्यू की जरूरत नहीं होगी, इट इज फॉर्मूला बेस्ड। तो ट्रेनिंग डेटा इज नॉट रिक्वायर्ड इन दिस केस। चेक्स इज आल्सो रिक्वायर्ड। चेक इज समथिंग लाइक कंस्ट्रेंट कि दिस वैल्यू, ये पैरामीटर इससे बड़ा नहीं हो सकता, या इस पैरामीटर की वैल्यू इसके बराबर होनी चाहिए। यू कैन हैव सम चेक्स फॉर दैट। ओके, वंस यू स्टार्ट रनिंग, ये थोड़ा सा कंप्यूटर थोड़ा स्लो भी है और ये थोड़ा सा टाइम कंज्यूमिंग भी है। ओके, इट विल टेक सम टाइम। It will give you all these iterations running. हाँ, वो मैं आपको in the meantime I'll try to show that. ये ऑब्जेक्टिव फंक्शन है जो मैं आपको पहले कह रहा था। It's going to take some time. MATLAB is itself is slow. MATLAB is okay for रैंडम प्रोग्रामर, मतलब बहुत थोड़ा सा काम करना है, थोड़ा सा कर लो तो MATLAB इज ओके, अदरवाइज इट इज़ वेरी टाइम कंज्यूमिंग। इस तरह का सिनेरियो जैसे मेरे पास अभी मैं आपको दिखा रहा हूँ, इट्स क्वाइट हेक्टिक इन दिस केस। तो अभी मतलब शुरू नहीं कर रहा है, इट्स बिजी ओवर देयर आल्सो। अदरवाइज इफ पॉसिबल प्रेफर सी लैंग्वेज। मैंने जो बताया एक छोटा सा काम है और इट इज टेकिंग अबाउट 15 मिनट्स फॉर आइट्रेशंस, one iteration, and in C it's only taking 2 seconds.
Good afternoon, sir. I am from NIT Greater Noida.
जी
I wanted to ask one thing.
जी जी
Is there some tool available, GUI based tool available for PSO in MATLAB?
देखिए, this tool is available on my website drsatyesh.in. You can download it from there.
Sir, will you be giving some demonstration on that, how it can be used?
This is what I am showing you.
Okay. And how can we add it in our Simulink based program?
No, I have not created a Simulink interface for that, but if source code will be available, yes, you need to take there is a structure at the back end, and you can use it and port it into workspace and use it in Simulink environment. It is possible.
Okay, sir, that will be a great help. Thank you, sir.
मैं थोड़ा सा अपडेट किया था, मैं चेक कर दूंगा उसको। Otherwise, lot of it is also, I think, available on MathWorks. It is also बहुत है। वहाँ से मतलब देखिए, अगर कोई आप में से M.Tech कर रहा है तो you can use this type of tools. If you are working towards PhD, then try to avoid. This is just a general suggestion कि अगर आपको एल्गोरिथम के नट्स बोल्ट्स नहीं पता, आप एक्सपेरिमेंटेशन रिस्ट्रिक्टेड एक्सपेरिमेंट्स कर सकते हो। मैंने अपनी तरफ से कोशिश की कि ये सारे पैरामीटर्स मेरे को चाहिए होंगे एक्सपेरिमेंटेशन के लिए, द मैक्सिमम थिंग दैट आई कैन एक्सपेक्ट। लेकिन द प्रॉब्लम इज दैट वंस यू गो इनटू रिसर्च, you will identify some more parameters. You design your own algorithm, you can create more experimentation, more investigation. This is actually the research. If you use the algorithm, it's already available. I think in global optimization tool of MATLAB might be available there also. But the restriction is that you'll be doing all the experiments with the parameters, those are open for you. Otherwise, you cannot make changes. It will be better that understand the philosophy. That's why I just concentrated today on the philosophy part. प्रोग्रामिंग में स्टार्टिंग में थोड़ा सा यही था कि भी आप प्रोग्रामिंग से कंफर्टेबल हो तो मैं आपको एल्गोरिथम की फिलॉसफी प्रोग्रामिंग से रिलेट कर दूं तो आप कर लोगे। मैटलैब में ही करना है, प्रॉब्लम इज इट इज स्टिल बिजी, तो इट्स एक्चुअली टाइम कंज्यूमिंग प्रोसेस। Another problem here is that it is a bit slower at this time. Otherwise, मेरा कंप्यूटर थोड़ा फास्ट तो है, लेकिन it's giving problem now. Otherwise, जो प्लॉट मैंने आपको दिखाया है वही सेम चलेगा। Write programs in C, and there is one advantage in MATLAB. Create your programs in parallel code. आज की डेट में हमारे पास MATLAB में पैरेलल प्रोग्रामिंग की फीचर अवेलेबल है, तो एक्सप्लोर दैट फीचर फॉर राइटिंग algorithms like this. Those are computationally intensive. That advantage can be encashed if you have graphics card inbuilt in your algorithm. Graphics card can help you in making faster computations done on GPU core. Okay. Otherwise, if not even then possible, then prefer C language. Okay, chalega. Till then, any other query? I think you got that idea that philosophy समझ आ गई, उसका algorithm के साथ में relation समझ आना चाहिए। बाकी जब आप काम करेंगे, you'll come to know that there there can be some more experimental parameters. Every optimization algorithm has two features. Understand that at the very first stage, that will be helping you in designing new algorithms also. It should have exploitation capability and exploration capability. If it is having only exploitation capability, not exploration, after some time it will terminate. Let us say I'm having some features added into in your local swarm. You have some features, some parameter values. To have new parameter values, you should have a mechanism into the algorithm. Let's say 1 to 10 values are available in my algorithm, या जो भी स्वाम है उसके अंदर 1 to 10 के बीच में एक्सपेरिमेंटेशन कर रहा हूँ, क्या वो -1 to 10 के बीच में भी हो सकती है? क्या वहां पे मेरे को रिजल्ट अच्छा मिल सकता है? To acquire that value, you'll have to go for exploration, new values. Exploration is something new values into your swarm, जिसके साथ में आप और कॉम्बिनेशन परम्यूटेशन जो भी आप कॉम्बिनेशन जो हमारे एल्गोरिथम की जो ड्राइविंग फोर्स हैं, जीए हैं या पीएसओ हैं, जो ड्राइविंग फोर्स हैं, उनकी फिलॉसफी जो है, that will help you to exploit that. Okay, I think this is going to take a lot of time. Whatever the plot I have shown you is going to give you the same result. It's a this type of plot you will be seeing there. Okay. Yes, any other query, please? Yeah, it can be. Simulink is nothing but you will have to make that. There are some programs. I'll give some idea. Once you open that file from MATLAB environment, there is one NI tool where your interface is. Okay. There is another NI GUI, NI plots. The plot figure is there. Then run NIT. NIT is nature inspired tool. RD रीड एक स्ट्रक्चर को रीड करने के लिए है. जितनी भी एम फाइल्स आपको मिलेंगी, ये तो शेफ्ट फंक्शन तो ऑब्जेक्टिव फंक्शन है. एंड देयर इज वन रन एनआईटी की टूल को रन करने के लिए जो एल्गोरिथम है जो इसके अंदर है. ओके, आपको अगर सारे पैरामीटर एक यूजर इंटरफेस लिया, उठा करके रन एनआईटी को दे दिया, उसने कुछ कैलकुलेशन करी, रिजल्ट निकाले, प्लॉट को दे दिया, वो प्लॉट है प्लॉट एनआईटी. ठीक है, एनआईटी प्लॉट. तो ये ऐसा है, इसका वर्किंग मैकेनिज्म है कि यूजर इंटरफेस से उठाया, वो एक बार ही उठाएगा एक्सेल की फाइल, बाद में कैलकुलेशन करेगा. रन एनआईटी का मेन काम है. उसके अंदर जो भी आप थोड़ा सा अगर टाइमर का चेक लगा सकते हैं तो आप उसमें से जो आपको टाइम कंज्यूमिंग है, आपके एल्गोरिथम में टाइम कंज्यूमिंग पार्ट है, उसको सी में कन्वर्ट करके वापस उसको EXE को यूज कर लो. ओके, देन वो कैलकुलेशन होने के बाद जो भी रिजल्टेंट बनेगा वो एक्सेल फाइल के अंदर लिखा जाएगा और साथ साथ आपको प्लॉट भी करेगा. तो इसके अंदर जो रिजल्ट आएगा, जैसे इसके अंदर जैसे स्फीयर वाला जो फंक्शन है, स्फीयर की जो एक्सेल की फाइल है, इसके अंदर आई थिंक पुराना रिजल्ट पड़ा हो तो मैं आपको दिखा देता हूँ. ट्रेनिंग डेटा कोई है नहीं है इसमें, इट्स ओनली नल, कोई इसमें रेंज नहीं दी गई. तो आपके कितने पैरामीटर हैं, उनकी वैल्यूज, तो उसके साथ में एक कॉलम मैंने स्पेशल रखा हुआ है, खाली रखता हूँ नॉर्मली उसको पहले. तो जब कैलकुलेशन कंप्लीट हो जाती है, लास्ट का जो बेस्ट रिजल्ट होता है उसको उठा करके उसमें डाल देते हैं, ताकि आपको कहीं और से ढूंढना ना पड़े. आपने जो एक्सेल फाइल दी थी उसी के अंदर आपको रिजल्ट मिल गया आपके. सॉरी, थोड़ा कनेक्टिविटी होने के कारण थोड़ा स्लो हो गया है सिस्टम. मैं इसका वीडियो बना करके यूट्यूब पे ही डाल दूंगा, दैट विल बी मोर यूजफुल लेटर ऑन. मैंने इसका मैनुअल नहीं बनाया, आई एम सॉरी वंस अगेन फॉर दैट. इसका यूट्यूब वीडियो बना करके ही ऑनलाइन डाल दूंगा. यू कैन गेट हाउ इट इज वर्किंग. गुड आफ्टरनून सर. बोलिए जी, कौन है?
I am from JSS Hanuman Rao.
Ji.
Sir, during my MTech thesis, I had applied GA for mobile handover problems.
Pardon?
During my MTech thesis,
Uh-huh.
I implemented this GA for mobile handover problems.
Okay, okay.
And the results were quite satisfiable, and it was very much acclaimed by the person who took my Viva.
Okay, okay.
Now I would like to further enhance my knowledge in this.
Mm-hmm.
So will you please help me out, sir?
What kind of changes you are supposed to take care of? What was your problem? It is a handover problem is a one domain of application of GA.
Yeah.
Exactly what was the problem?
The problem was like during handovers, what was the minimum power requirement? So I took the minimum power algorithm and then I applied GA by using a fitness function. Then I came out with a result.
Okay.
So yeah.
Okay. To some extent, I got that idea.
Yeah.
In handover problem, there is one decision-making issue.
Yes.
When to hand over, when not to hand over.
Yes.
Okay. This problem is solved by fuzzy systems also.
During this handover problem, the power requirement is very important.
Yeah. This decision-making problem was solved by fuzzy logic also. In many research papers, it is done.
Yes.
There is scope of improvement in that. How it is possible? देखिए अगर हमें उसमें जो signal की जो strength है, that is very important, and that signal strength varies with the environmental conditions.
Yes.
And that is also location specific, and the infrastructure around the location where we people are talking about, that matters a lot. You can take it to type 2 fuzzy logic system and get it evolved using PSO or GA. The same problem can be solved, isn't so?
Whatever the parameters that you don't know right now, that is, one is the locality and the signal ratio, and then the other one is the power, minimum power requirement for the battery. So this will be my next.
Okay, this is the problem that you have taken in your PG. Now you got to extend it to multi problems. It's not only going to be one problem for PhD.
Yes.
So try to think about in the similar domain other problems relevant to that domain.
So I have drafted a plan how to go about it.
नहीं देखिए whatever thing that I am trying to suggest you, that is your application area for your PG research. During PhD, we'll have to take a whole domain, all the problems in that domain. It is to be, these all problems has to be addressed. So you can explore GA, PSO, or fuzzy logic for the application that you are talking of. Handing over of a signal to one BTS from another BTS, I think it will be good for you. Although a lot of work is done in that. There is another scenario that comes into my mind, that is 3G or 4G. You can talk about that. Even forecast about the 5G problem relevant to handing over of a subscriber. Getting the point?
I got that.
Yeah, you'll have to refer to the latest research, whatever is done till date. Until unless you do not put innovation into that, it won't be accepted by the public.
Okay. But in this, during this thing, like if I have any query, can I ask for you?
Yes, please.
Okay, sir.
Okay, I think you people may have my number. It was given there in the first slide.
Yes, sir. I have gone to the website. I have got all the details.
Yeah, you will get it.
Yes, sir.
Yes, any other query?
No, sir. But sir, your particular lecture, what you have given from right day from the morning, it was highly knowledgeable, sir. I got all my things here.
I'm sorry for that. I'm sorry for that. This is actually something system problem. I'm also facing the similar problem while you are asking me questions.
Yes, sir, but overall, like I was not going like how the parameters should be given to a real system. But after looking at your work, what you have done in 2011, when you showed me the slides, I was very impressed, and it helped me have a great extension in my idea building. How actually the research will build up. The thing that you showed the slides right from the beginning, like the basic.
Don't go into my research area. That will not be of much use. But the objective that our discussion was oriented about the philosophy of the algorithm and their requirement and their efficiency or the usability into your domain area.
Okay. So that is what.
That will help you more. Okay, whatever the thing I have presented is all done 4 years, 5 years back. According to me, it is obsolete.
Okay, sir. Thank you very much, sir.
That's it. Thank you.
So first of all, thanks, sir, for such a wonderful lecture. And by the way he delivered itself, it is understood how much knowledge he has and how much depth he has gone into this topic. And I think he was an apt person in this thing. And many of us, like, we are from different different levels, we can say. So for any teacher, it is very difficult. We don't know the audience and to which depth we have to go. And but he has very clearly, so that even the person who's doing it first time or the one who has already done, he has cleared it in a very different, like he has taken the lecture in a very different manner. And I really thank sir for such an effort. And now again, all of you can go for lunch, and we will be meeting back at 2:45 because we are a little late. So again, we'll meet back at 2:45. Okay, so the next lecture we will start at 2:45. It is on fuzzy logic. So all of you at sharp 2:45 get assembled. Thank you, sir. वो बहुत ठीक था. तो actually वो tax भी आपका कट किया होगा. Like आपके lecture का. बाकी 3,000 आपका and ये अभी यहाँ जो he has just specification वाला नहीं दिखा, तो वो बोल रहा था कि rate के according एक minimum चाहिए वो कैमरा इसका specification देखा तो फिर हम वहाँ वो मैं मिलवा लेते लंच के बाद सर. यहाँ पे आना. ओके. हाँ हाँ हाँ. तो वर्मा सर का नंबर देखना.
अच्छा. हाँ जी
अरे ना पेपर बना रही थी ठीक है मैं सर वो में सेट नहीं हो रही मैं सारी ऑप्शन पे जाके देख
रन करो. क्या हो गया? स्लो होके लगता है. बोर्ड की फाइल खोलो जैसे चुना है.
GUI इंटरफेस सर ये MATLAB में बनाया आपने?
हाँ ये मैटलैब में बनेगा।
उसमें से कोई किया कोई रेफरेंस?
नहीं नहीं, डोंट फॉलो बुक्स। अगर आपने सर्च करनी है तो फॉलो, डोंट फॉलो बुक्स, बहुत टाइम लग जाएगा।
जीआई सर उसको मैं मतलब कैसे आइडिया
2 साल में थोड़ा बताऊँ।
आप बताइए।
हाँ।
नीचे से
तो मैंने उसको वर्ड के पीडीएफ बना के वहाँ पीडीएफ फाइल खोल दी।
हाँ नहीं, वो वर्ड वाली फाइल खोलो ना। एक्चुअली को वर्ड फाइल आपने मार्जिन उसमें खत्म नहीं किए, उसका मार्जिन खत्म।
सिखाओ कि कैसे करूँ।
अच्छा
मैं ना अपना पेपर खोलती हूँ, उसमें से मेरे को फिगर देख के बता दो कैसे मारा है। ये सारा काम करती हूँ। वो सारे खत्म करके मारती हूँ। हम जाएंगे कैबिन में चले जाएंगे, बिकॉज ये भी लंच आके फिर बहुत टाइम भागना है।
ठीक है ठीक है।
थैंक यू सर।
तो आप लोगों ने पीपीटी लिया था, मुझे भी मेल कर देना। ओके
ले नहीं।
अरे सर वो करिए।
अच्छा ठीक।
नहीं सर, ये बता दो, मैंने वो वर्ड फाइल खोल दो। आपको क्या आ जाना मैम सर के साथ मेरे कैबिन में आ जाना मैम। बहुत टाइम लगेगा आपको ये सीट पे रिकॉल करनी है। ओके ब्रेकफास्ट भी नहीं किया, ऐसे आए हैं। मुझे बोला एक घंटे से 2 घंटा हो गई, एक नहीं 2 लेक्चर दिया तो तो बस नीचे नहीं आएंगे मार्जिन का। उस दिन जब आपने किया आपको बिल्कुल ही मार्जिन खत्म हो गया आपकी।
हाँ लंच ब्रेक हो रहा है।
Hello.
तो मकान एक 10वीं कॉलोनी में जैसे अबाउट टू 10वीं ऐसी कॉलोनी बहुत बड़ा है ना मेरे लिए।
कोई बात नहीं। क्या पता डायरेक्ट तक कॉल कर रहे हो मैं तो बता रहे कॉल एक सारा बंद नहीं कर रहा कॉल एक बंद करके हां
Yes, but I'm ready, but I'm not looking like
मालिक बंद है
नेट तो चल रहा है।
अरे नहीं, मैंने स्पीड है अभी खाली पड़ा माइक चला जा।
कौन सा ये है ना 1 वाला?
सामने आता रहा भाई।
अच्छा यही है।
खाली पड़ा।
Okay, mic on now. Good afternoon to all of you. I'm Dr. Linny Matthew. Again, taking another lecture. I think this is the third lecture of mine in this course. Good afternoon to all the participants in the various nodal centers. This session, we will give an introduction of fuzzy logic, and then afterwards, Shimi will be using this fuzzy logic in the next simulations. Okay. So I'll take a lecture on starting from the basics of fuzzy logic. So what do we call as a fuzzy logic? When we hear the word logic, we all remember the word Boolean logic or binary logic. And we are very familiar with the word Boolean. And you know also that there are only two numbers or two states, 0 or 1 or true or false. But in fuzzy logic, it is the multi-valued logic that allows intermediate values to be defined between 0 and 1. Okay, so it has values between 0 and 1. It is not that it has values only 0 and 1. And it is based on natural language, and it is initiated in 1965 by Lofty Sadeh, Professor of Computer Science, University of California, Berkeley. This slide I'll read on, but as we go on, we will understand what all are the various characteristics. It is conceptually easy to understand, flexible, tolerant of imprecise data, nonlinear functions of arbitrary complexity can be modeled and built on top of the experience of experts, and it can be blended with the conventional control techniques like PID and other techniques. Before we go on to fuzzy logic, let me define some terminologies in this. First is the fuzzy set, because the fuzzy logic, the concept of fuzzy logic starts with the fuzzy set. We are all very familiar with the word set and the Venn diagram, where we define a universe of any values and define each set. There we say that a particular member or a particular value is a member of a set or not a member of a set. Okay, such sets can be defined as classical set, or in some books they are again called as crisp set. So a classical set has a clearly defined boundary, whereas a fuzzy set does not have a clearly defined boundary. See here, a universe is shown and there are some elements and a set is also there. The set is a set of red balls and all the blue balls are outside the sets. So we call the blue balls as non-member of the set and red balls as the member of the set. But when you come to define the fuzzy set, as the definition says, it does not have a clear boundary. That means some elements lie on the boundary itself. So there are elements which are members, there are elements which are not members, there are elements which are partially members. Okay. So now let me define another word called membership value. So the members have a membership value 1, non-members have membership value 0. And these members which are partially members can have values between 0 and 1. Okay, now let's see another representation. See here, X is a set of all real numbers from 1 to 10. We call it as a universe. Clearly we call it as a universe of discourse. Here A is a set of real numbers between 5 and 8. So 5, 6, 7, 8 have a membership value 1, and 1, 2, 3, 4 and 9, 10 have membership values 2. So now here I have drawn a figure which shows a membership function. X-axis are the members, Y-axis is the membership value. Some members have membership value 1 and some have membership value 0. Okay, so a membership function or a graph where we represent the membership value with respect to the members. X-axis is the members 1, 2, 3, 4, 5, 6, 7, 8, you can see that. And the members have membership value 0 and 1 depending on the membership. Okay. Now if we take another example, very critical word I am using there. B is a set of young people. See, nowadays people don't want to show that they are very old. Like, you know, they every time everyone wants to be very young only. So here, young is a very fussy term. So that's why I used it. Now here, there's a table and there are various members whose age is given over there, 65, 27, 17, 32. And the membership values are also given, 0.31. So here there are some members which are members, some are not members, and some are partial members. We have divided a area 20 to 30 as the transition age, which we say have partial members. You can make it 20 to 40 also, 20 to 50 also. Okay, depends from people to people how they want to define young people. Okay. Now, this, you have seen what a fuzzy set is. Now, a set of young people is a fuzzy set. Okay, one more thing I'll tell you here. Now, if I define A as a set of old people, what will be the membership values of 65? 1. Okay, 17 will be 0. Okay. Similarly, you can have different sets. Set of middle-aged people, set of very old people, set of infants, babies. So, these linguistic terms, that is the word I wanted to tell you now. There are some linguistic terms by which you define. Okay. So, now I have already defined, again I'll read this. Membership function is a curve that defines how each point in the input space is mapped to a membership value or degree of membership. So, membership value can also be called as a degree of membership between 0 and 1 and is often designated by mu. So, mu is the membership value. It is defined or designated as mu AX. So, X is the member, mu is the membership value. What is A? A is the set. Now, when I told you A is the set of old people, mu A 65 will be 1. B is the set of young people, so mu B 65 will be 0. So, for the same member, depending on the set, the membership value will change. Okay, so mu AX is the definition or the designation of a membership value. Okay, now in this figure, here a fuzzy set is defined. This is actually the seasons, summer, winter, autumn, spring. We all know the months. This time, as you know, the winter is so delayed. Even in January, we don't have much cold. So, there is nothing like on December 1, the cold season will start, and on February 1, the season will finish. No. We cannot define a particular shape. It is a gradual change. So, the membership function can have different shapes. Okay. And here, the word seasons will be known as the linguistic variable, and the associated values spring, summer, fall and winter are known as the linguistic terms. Okay. What is the meaning of the word linguistic? Okay, related to a language. See, when we learn fuzzy logic, see, why do we require fuzzy logic? मैं पीछे थोड़ा सा आ जाऊँ.
Ma'am, so that we should not stick to a certain value, we should have a range to get the better.
Okay, any?
Imperfections in the input.
Okay, good. ठीक है, good. Any other idea? See, fuzzy logic, the idea of fuzzy logic, as you know, is not used for artificial intelligence and all at a time. It was simply a mathematician of California University started it. See, it is considered as a technique of artificial intelligence or imbibing artificial intelligence into machines because human beings think fuzzy. If I ask you what is it today, temperature is little bit colder. What is the temperature today? It's cold, okay. Another person, it's colder than yesterday. Anything else? Eh? Not so cold. Anyone else? Anyone else have any other idea? You did not tell me, ma'am, it is 25 degrees Celsius, 10 degree, 10.3. Why? You said it is colder than yesterday. It is cold. It is not so much cold. That is how human beings think. We define our variables. We define things as linguistic terms only. We very rarely specify things crisp. Okay, I don't like that person. Why? He is not very friendly. See, we think fuzzy. So, the fuzzy logic, whatever the logic, we have to convert it into a linguistic term. Or in the other way, the linguistic terms will be converted to mathematical terms so that the machines can understand it. Again, both ways. So we require to define variables in terms of linguistic terms. So here, a linguistic variable, if I take a linguistic variable as a temperature. Okay. So when I talk about a word temperature, you always will think of a temperature from 1 degree, 0 degree Celsius to 100 degrees Celsius. Okay. And you may say, "Aaj cold hai, ma'am," so you may have an idea of a 10 degrees Celsius. But a furnace, foreman who is working on a furnace, okay, he will say, "Furnace thanda pada hua hai, madam." Temperature kya hai? 1500 degrees Celsius. And the furnace thanda pada hua hai. The word thanda he is using for 1500 degrees Celsius of the furnace. So the same linguistic term will have a different meaning with another person and a different meaning with another person. Okay, so that is what I'm saying. You can define the linguistic variables into various linguistic terms. Okay, we will come to that. So the membership functions are subjective measures for linguistic terms, and as I told you earlier, there are many types of membership functions. Shapes, it can be triangular, it can be trapezoidal, Gaussian, bell shape, okay, depending on. One more thing, when I show you a triangular membership function, what is the meaning of that? What is the meaning of a triangular membership function? The shape is triangle. That is what you are saying. Okay, good. Any other idea?
There are 3 values, like from minimum value, maximum value, and 1 get
Okay, okay. Any other idea? See, the x-axis is members and the y-axis is the membership value. Membership function. So the y-axis is membership value. So on this, it shows clearly that only one member has maximum membership value. Only one member has maximum membership value. Whereas when you see a trapezoidal membership function, you can clearly understand that there are more than one members with maximum membership value. So it depends on the criteria or the situation where you are working. You have more than one member, then you go for a trapezoidal membership function. Or you go for a Gaussian membership function where your members, most of the members have higher values. So it is different types of membership functions can be selected by using this. Okay, let me go. Now a little bit of arithmetic. As we use fuzzy sets, in classical set also we have some fuzzy set operations like intersection, union, and negation. Here also you have such operations on the fuzzy set, but it is a little bit different here. Okay, so we will see how we do it. See, I'll go to that slide again now. I am taking an example of a set. That set is known as interval between 5 and 8. Numbers between 5 and 8. So 5 to 8 has membership value 1. Some values less than 5 has membership values between 0 and 1. Similarly, 8 ke baad kuch numbers have membership value less than 1. Okay. Similarly, another set is a fuzzy number about 4. So 4 only has the membership value 1. Others have membership values between 0 and 1. Now if I combine these two, if I intersect these two sets, first picture shows the union, the second picture shows the intersection. You have no doubt about it. But now, how will you find out the union? To find the union, we go for the maximum values of each membership value. We go for the maximum of each membership value. For the intersection, we go for the minimum of the values. Okay? And for negation, we go 1 minus mu. 1 minus mu. Now I will take the previous slide. Negation is membership value not x is equal to 1 minus membership value of x. Intersection is membership value of x and y. Intersection mein and lagta hai. X and y is equal to minimum of membership value of x comma membership value of y. Whereas union x or y, maximum of membership value of x and membership value of y. Okay, I'll take a simple example for this. See, a set A is, a fuzzy set A is defined here. 1 by 1 plus 0.7 by 10 plus 0.4 by 20 plus 0 by 40. See, one thing I wanted to tell you is, this is a representation which the author T.J. Ross, Timothy J. Ross uses in his book. Different authors uses it in different ways. It is nothing to do with addition and division over there. It simply shows that 1 is the membership value of 1, 0.7 is the membership value of 10, 0.4 is the membership value of 20, 0 is the membership value of 40, 0 is the membership value of 80. Some authors use comma for the plus, and 1 by use nahi karte. So there are two sets here, A and B. What will be A union? 1 by 1 plus 1 by 10. Consider each of the membership values. 1 and 0.3 you compare, 1 is the maximum value. 0.7 and 1 is maximum. So you write 1 by 10. 0.4 and 1 by 20. 0 and 0.5, 0.5 by 40. 0 and 0.2, 0.2 by 80. 0 and 0, 0 by 100. If it is A intersection B, same procedure, you take only the minimum of it. Okay, negation, all those. Okay, and here the De Morgan's law also apply. I don't have time, so I am not doing all those exercises, making you do all the exercises. You can go. If you have any doubt, you can refer that book of Timothy J. Ross of Fuzzy Logic. Okay. A union B. See the A and B, see. Each of the membership members, 1 ka 1 and 0.3 are the membership values. 1 है, so 1 and 0.3 are the membership values. So A union में maximum लेंगे. So this we take. Here 0.7 and 1 है, तो 1 we will take. 20 के लिए 0.4 and 1 है, 1. 40 के लिए 0 and 0.5, so we take the maximum value. 0 and 0.2 we take 0.2. That's all. Same negation. Now, once you have a fuzzy set, you can define relations between the sets. Here I have shown a classical relation, or we call it as a crisp relations. See, whenever we hear the word relation, we always think of our father or a mother or wife or brother or sister. True. They are relations only. Okay. Now here, there is in this picture, see this picture. There is a relation from with 1 to A, 2 to C, 4 to C, but 3 to B. Okay. That same relation can be written like this also. See here, R is equal to 1 comma A, 2 comma C, 3 comma B, 4 comma C. This picture is known as a sagittal diagram. Sagittal diagram, when you draw lines and define it. This is a relation matrix. You have 1, 2, 3, 4, A, B, C, 1 and A, there is a relation, you write 1, no relation 0. Okay. When we talk about fuzzy relations, then the relation values are not 0 and 1 only. There the relation values are between 0 and 1. So in a binary relation, there are only two conditions. You have a relation or you don't have a relation. But in fuzzy, the magnitude of the relation mein thoda difference hai. It is true with us. We have more relation with someone and don't have relation with another person, or less relation. We go very rarely to those people's houses. So we can define it as 0.3 or 0.2 or 0.8 and 0.9. समझ में आ गया? So there is always, the relationship is always fuzzy. It is not that 0 or 1. So here, when we go for a fuzzy relation, you have the relation values 0.2, 0.3, 0.3, 0.5. Now, how can we make a fuzzy relation from two fuzzy sets? See here, when we talk about a fuzzy relation, that is always between two different universes. It is not that same values, x1 के साथ x1 का क्या relation है, x2 के साथ x2 का क्या relation है. That does not work. x1 और y1 का क्या relation है, x2 और y1 का क्या relation है, x2 और y3 का क्या relation है. Yes, there is meaning in it. So there is always a relation between two different universes. So here, mu r x comma y, r is the relation. That means we call a technical word as Cartesian product. So there is a Cartesian product A cross B between x and y. And how we do it? Minimum of mu ax comma mu by. Now how do we do it? We have two sets A and B. Now I don't have to explain what x1, h2, h3 are and y1, y2, y3 are. They are members of a universe x and y. Now I make a relational matrix here, see, x1, x2, x3, y1, y2. x1 and y1, see, x1 and y1 may you have two membership values, 0.2 and 0.3. What is our definition? Minimum. So the value minimum will come here, 0.2. Similarly, x1 to y2, minimum 0.2. x2 to y1, minimum is 0.3. So you write here 0.3. x2, y2 minimum is 0.5. So from two fuzzy sets of different universes, you can make a fuzzy relation like this. Now you will ask me, madam, आप intersection में भी minimum use किया, इधर भी minimum use किया, ये कैसे हो सकता है? ये सेम नहीं होना चाहिए, सेम नहीं हो रहा है, नहीं हुआ, क्यों सेम क्यों नहीं है? different element नहीं है. The relation is always found between two universes. I usually give an example of a relation between color of a fruit and its grade of maturity. As you all know, केला भी हो, आम भी हो, orange भी हो. As the maturity, as the fruit matures, the color changes. It's a common nature's rule. So here we are defining the color of a fruit, that is the linguistic variable, into three linguistic terms: green, yellow and red. Similarly, the maturity of the fruit we are defining into three linguistic terms: verdant, half mature and mature. Means kacha, pakka, adha pakka. Okay, that's the real word for this. Now we are going to find out a relation between red and mature. Two terms. Okay. Now see here. If I define it using membership functions. Imagine red is defined with a red triangular membership function and mature is defined with a blue trapezoidal membership function. When I take the minimum of it, it is not the same as the intersection. Why? Here we have two different universes. So it is represented as a three-dimensional picture. So here, this membership value is same here. This axis is showing the color and this axis is showing the maturity. So this is the triangular membership function and this is the trapezoidal membership function. So the minimum portion of this comes, this portion which comes under that. So this is a relation R. Okay, so the relation is always between two fuzzy universes. Okay, now I have one more important terminology to explain you. That is the composition. Here, first two matrices is shown here. First matrix is a relation between the universe X and Y. Second is a relation between Y and Z. Now, if you want to find the relation between X and Z, if I want a relation between X and Z, then we do what we call as a composition. There are two types of compositions: max-min composition and max product composition. Okay, I'll show you the max-min composition now. See, I have an example. The first relation is between 1, 2, 3 and A, B, C, D. I have taken a different example. There are fuzzy values as the relation values. Next is A, B, C, D and alpha, beta, gamma. So if the sagittal diagram is drawn, it will look something like this. Now if I want to find a relation between 1, 2, 3 and alpha, beta, gamma, we are going to use a max-min composition. Okay. This max-min analogy composition is a very important composition. That's why I wanted to, for explaining that only I've come out with all these fuzzy set, fuzzy relation and all. Okay. So here, see what I'm going to do. See, I have to find out a relationship between 1 and alpha. So I take the row of 1, 0.1, 0.2, 0 and 1. And the first column 0.9, 0.2, 0.8 and 0.4. Dekh liya na aapne? Now we apply a max min over there. What we do? Each of this 0.1 and 0.9 ka minimum, 0.2 and 0.2 ka minimum, 0.0 and 0.8 ka minimum, 1 and 0.4 ka minimum. And the maximum of these four minimums. So the first minimum is 0.1, second minimum is 0.2, third minimum is 0.0, fourth minimum is 0.4. The maximum of these is 0.4. So the relation between 1 and alpha is now 0.4. Now we'll go for the next 1 and beta. Do the same exercise. 1 and gamma. Similarly, 2 and alpha, 2 and beta, 2 and gamma. We get a relation like this and a sagittal diagram like this. Now my question is, why max min? See, Ross explains a chain strength analogy for this. I don't have a board here to draw a diagram actually. See, he says that he takes a simple example for this. See, imagine there are 3 chains. Chain, you know, na? Usko kya bolte hain Hindi mein? Which has links. Chains are connected like this, na? Links ke saath. Okay. So such chains, 3 chains are connected in parallel, connected at the ends, and a force is applied on both sides. See, the force is applied to that extent that the chain breaks. So it is true that one of the chain will break. Okay. So if one of the chain breaks, the system has not failed. We are again using it. Why? 2 chains are there. Because 2 chains are there. Again you will continue using it. Second chain also broke. And the third chain, when it breaks, you say, abhi to repair karna padega. ठीक है, स्टेपनी हम रिपेयर नहीं करता है जब तक दूसरा टायर भी वो चलता है. सिमिलर स्टोरी. तीनों चेन ब्रोक हो गया. Now my question is, which of the chain sustained the system? Last only. See, which of the link broke first? The weaker link. वो chain का weaker link broke. Next chain का भी weaker link broke. The third chain ka weaker link broke the last. So the weaker link of the last chain sustained the system. Now compare the 3 weak links. Which one sustained? The strongest of the weak links sustained the system. Did you get my point? Of all the strong links in the chain, did not help. But the strongest of the weaker links sustained the system. So Ross says that the maximum minimum operation is the common most popular operation or most popular composition which can be utilized for almost all engineering applications. Okay, that is the composition which sustains a system. That doesn't mean that you cannot use min-max. There are stages or problems where you use min-max also, max-max also, min-min also. There is another one written here, max product composition, depends from problem to problem, solution to solution. But the common one which we use is the max-min, and this is known as the Mamdani composition. And you read through papers, you very often find this word Mamdani, M-A-M-D-A-N-I. Mamdani composition. So this max-min composition is the very common Mamdani composition. Okay. Now here, as we go on, we use this Mamdani composition very often. That is why I defined all this fuzzy set, fuzzy operations, fuzzy relations, and fuzzy composition to explain that max-min composition. Now when we go for a fuzzy control system, fuzzy logic has various applications as we go on to literature and papers. So this class, I go into fuzzy control system and the fuzzy toolbox where we use the fuzzy inference system that I'll explain. To define a fuzzy control system, as you all know, any control system has a black box, inputs, outputs, and the transfer function or the block. So here also, when we define the fuzzy control system, we have three main steps to be done here. This is defined, this procedure is originated by Ibrahim Mamdani. This is the person who defined it. Three steps are taken to create a fuzzy controlled machine. They are the fuzzification. Fuzzification is using membership functions to graphically describe a situation. And defuzzification is the opposite of that, to get the crisp results. And rule evaluation is that you make some rules and apply the rules. Okay, now we will see all this one by one. See, fuzzification, as I was telling you, is the process of making the crisp quantity into a fuzzy quantity, or having a graphical relationship of the inputs in a fuzzy form. Okay, so as I have defined membership functions, the whole process, the inputs and outputs of the process are characterized in the fuzziness or as a fuzzy set. Okay, there are various methods of doing it. I told you Ross defines various methods. First and the popular method is the intuition method. What do you mean by the word intuition? By imagination. Okay. Guesswork. Okay, so that is actually, so it is not actually a guesswork. It is done by a past experience, and if I ask you to fuzzify by intuition to all of you, all 20-25 people sitting here, you may fuzzify those into 25 different ways. Okay, so it is completely on our own experience. Okay, so many a time to get a correct input, we go for an expert opinion who knows the system. If you know the system, then it is well and good. Okay, like sometimes I give an example of defining or designing a fuzzy washing machine, because everyone knows, we all are very much expert in washing clothes. Okay, so we all know कितने पानी चाहिए, कितने सोप चाहिए, कितने बार उसको पानी से निकालना है. So it is easy for us to design a washing machine. Maybe you may not be able to design a fuzzy controlled furnace because you don't have experience on it. So there is always this intuition is on the experience of the experts. Okay. For defuzzification is the conversion back to it. Okay. So output of a fuzzy process can be the logical union of two or more fuzzy membership functions, because we are giving the input in membership functions, so you get the output also as a membership functions. So from the membership function you have to find out a crisp value of that output. So to find out the crisp value back, there are various methods, math memberships, Android, weighted average, but the common and the popular and the accurate method is the centroid method. Okay, now let me take a simple example. I'm explaining this example and do this in the fuzzy logic toolbox. See, the example is of an inverted pendulum. The problem is to balance a pole on a mobile platform that can move in only two directions, to the left or to the right. The platform can move only in two directions, and there is a pole on top of it which you have to balance on it. So the inputs to the system is the angle between the platform and the pendulum and the angular velocity of this angle. Similarly, output is the speed of the platform. Now the process of defuzzification. each of the inputs and the outputs, we define it into membership functions like this. Each of the variable, here the variable is speed, the maximum and the minimum range of that speed is defined, and each of these is divided into various different linguistic terms: negative high, negative low, zero, positive low, positive high, and each of these has a range. Negative low is from this value to this value, negative high is from this value to this value. So define that range. That is what I call as intuition. I told you all 25 will do it in different ways, because you may take a different range, you may take a different name, you may take different numbers, because I have put 5 here, you may put 3, 4, 7. So it can be different for different persons. You can define the linguistic terms or the membership functions. So here I have specified the inputs, angle and angular velocity, and the speed. Okay. Now we have to make some rules. See, I told you the intuition and the rules is completely dependent on the experience of the experts. And the rules are defined in if-then format. See how I have written the rule? If angle is 0 and angular velocity is 0, then speed is also 0. If angle is 0 and angular velocity is negative low, then the speed shall be negative. If angle is negative high and angular velocity is 0, then the speed shall be negative high. That is why the second slide I said that it depends on natural language. There is no complex mathematical analysis here. The whole system now you define in terms of some if and then rules. If this is so and this is so, then this is so. You can define the whole system with any number of rules. Now I have around 5 linguistic terms and 5 linguistic terms. You write that much number of exhaustive rules. So when you write the rules, you may make mistakes. So you can make the rules in a table like this. Many a time you have more number of inputs and outputs, you may not be able to make it as a table also. So sit and write the rule. But when you write the rule, it is very important that the rule should be very relevant. The rule should be relevant and it should be as per the experts. Okay. Once the rule is defined, now what is known as the rule evaluation. Please listen to me very carefully when I explain this rule evaluation. Okay, आपका concentration इधर उधर नहीं जाना है. See here. Now I have a crisp value of angle and angular velocity for which I require the speed value. अभी तक तो मैंने specify किया, rule बनाया बस. Now when I am going to evaluate the rule, a particular value of angle and angular velocity, crisp value is taken, and a crisp output is required. How will I get the crisp output? See here, this is the crisp angle value. ये जो 0.0 के पास जो value है. Similarly, this is the crisp angular velocity value. Now this value intersects these functions at these 2 points. Similarly, here also this actual angle value intersects the functions at these 2 points. Now what are the rules which involve these linguistic terms? Now the linguistic terms 0, positive law of angle, and 0 and negative law of angular velocity is involved. अभी हम देखते हैं इसका क्या रूल हमने बनाया हुआ है. The first rule is if angle is 0 and angular velocity is 0, then speed is 0. ये है ना हमारा रूल. ओके, अभी 0 वाला लिंग्विस्टिक टर्म लेते हैं. If angle is 0, ये angle is 0 में actual angle value is intersecting here. Some 0.75 value. Okay, here it is intersecting at 0.4. When I take this rule, if angle is 0 and angular velocity is 0, I am getting two values, 0.75 and 0.4. I will take the minimum of it. Maximum rule apply करना है ना? Minimum of it. So minimum of 0.75 and 0.4 for 0. Okay. Now what is the next rule? If angle is 0 and angular velocity is negative low, speed is negative. So angle is 0 में it is 0.75, negative low में it is 0.6. देखो आप ये रूल बनाया है. पहले हमने angle is 0, angular velocity is 0 लिया था. अभी angle is 0 and angular velocity is negative low लिया. So what are the two values to compare? 0.75 and 0.6. So we get for negative low as 0.6. What is the third rule? This is the rule evaluation. Third rule, if angle is positive low, angular velocity is 0. See what are we taking? ये positive low वाला value ले लिया and 0 ले लिया. Now this is 0.25 and this is 0.4. So when we compare these two, we take the lower value 0.25 for speed is positive low. What is the next rule? If angle is positive low and angular velocity is negative low, then speed is 0. ये इसका क्या values है? 0.25 and 0.6. कौन सा lower value है? 0.25. Now you have we have four rule evaluations here. One is speed is 0 at 0.4. The other one is speed is negative low at 0.6. Third is speed is positive low at 0.25. And then is speed is 0.25 at 0. ये चारों का एक logical union maximum. Now we will take a maximum of all this, a logical union of all this. What happens? We get a shape, a black shape like this. Here the value is 0.75, here it is 0.6, and here it is 0.25. देखो आप 0.25, 0.6 and 0.4. देखो here it is 0.6, here it is 0.4 and here it is 0.25. This is the logical union for which a black space, for which we are going to find the defalsification. Defalsification method हम कौन सा use? Various methods है. The simple method is the centroid of the shape. ये जो shape की center of gravity कहाँ पर है? The center of gravity of the shape will be found out here. और ये center of gravity की corresponding a point पे जो speed value आया, that is the crisp speed. ये बोलने में बहुत आसान है, इसकी mathematical calculation इतना आसान नहीं है. our ME students को मैंने आपको बोला ना, एक 6 महीने की कोर्स में आता है, ये 20 मार्क्स की क्वेश्चन आता है इसकी वैल्यू फाइंड आउट करने के लिए. सो सेंट्रोइड कैलकुलेट करना है, ये टेस्ट उसका सेंट्रोइड कैलकुलेट करना है. ये एक वैल्यू को लेके एरिया फाइंड आउट करके एरिया को डिवाइडेड बाय दी एक्स एक्सिस का वैल्यू लेके वी डू इट. एंड द बुक्स हैज वेरियस मेथड्स. मैंने आपको बोला ना, इन दिस इट विल. सो द प्रॉब्लम इज, अभी ये एक बहुत सिंपल शेप आपको मिला है, सेंट्रोइड फाइंड आउट करने में आसान हो गया. Depending on the complexity of the problem, the shape changes. You have more rules, more membership functions, more complex unions will be resulting. So finding the centroid is not an easy joke for you. There comes the utility of MATLAB fuzzy toolbox. Okay, now let me go to, by not wasting time, let me go to MATLAB. Okay, so let me conclude this with this fuzzy control by the time MATLAB opens. Fuzzy control system design is based on empirical methods, basically a methodical approach to a trial and error. So the first thing is that documents the system's operational specifications, inputs and outputs, define the fuzzy sets for the inputs and the outputs, document the rule set, determine the defussification method, and again run through it, validate the system. Okay. The fuzzy toolbox of MATLAB looks like this. So let us go for MATLAB. Okay. Now I will explain to you how we go for the fuzzy toolbox of the MATLAB. To go for that fuzzy GUI, which I have shown you now, type fuzzy, F-U-Z-Z-Y. Okay. Now a window has opened. Several windows will open. Okay, I will, if you cannot read the names of the windows I am speaking out, it is known as FIS editor. Let me expand it. This is the input, this is the output, and this is the process which we call as the mamdani. उसमें लिखा हुआ है mamdani. Okay. Now in our case, जो inverted pendulum जो case हमने अभी लिया है, we have two inputs and one output. Here only one output is shown. So we require two outputs. So go to edit, add variable, input. Edit, add variable, input. So आपका एक और इनपुट ऐड हो गया. ओके, आपके पास 4 इनपुट्स और 3 आउटपुट्स है, तो आप ये ऐड वेरिएबल तो करते जाइएगा. जितने इनपुट आपको चाहिए, जितने आउटपुट आपको चाहिए, ऐड वेरिएबल आउटपुट करने से एक और आउटपुट ऐड हो जाएगा. ठीक है, डिपेंडिंग ऑन योर. नाउ लेट अस टेक द फर्स्ट इनपुट. ओके, at this here you will see input 1. I'm going to change it as angle, and this is angular velocity, and this is speed. Okay, 2 inputs and 1 output. So the inputs are angle, angular velocity and speed. Okay. So now you had seen that coming out here. Here पहले input 1 था, ये अभी angle बन गया. Input 2 था, वो angular velocity बन गया. This is speed. Now the next is to define the membership functions. Okay. Going to the particular input and double click on this. Another window will open. And this window is known as a membership function editor. Let me expand it. Okay. Now another window opened where we are going to define the membership functions. See, the inputs and the output which you have defined in the previous window has come up now here. It is showing angle. Okay. Now here you have to define the angle membership functions. Okay, for that I have to show here the range. The maximum angle and the minimum angle should be defined. It is very clear. It is very important. Whenever you go for any fuzzy control systems, the maximum values and the minimum values of the various input and output parameters or variables have to be found out, and that has to be defined. That is the universe. Okay. So I'm going to write here -5 to 5. You can take any value depending on your problem. I am writing it as -5 to 5. Okay. So now you see it is come here now -5 to 5. Now the first membership value, let me write this as negative low. Here I can define the parameters. So it is already written there as -9, -5, -1. Now I am going to change it to -5, -3 and -1. What are these three values? See, these are the three indices. -5 पे एक इंडेक्स आ गया, -3 पे दूसरा इंडेक्स आ गया, -1 पे तीसरा इंडेक्स. बस that's all. Now this is the second membership value. I am taking this as 0. I am not making any change. वैसे मेरे पास time भी नहीं है. This is the positive low. Okay. Here I am going to make this as 1, 3 and 5. I'm going to delete that 9 here. Okay. Now go to angular velocity. Here I am going to do it as -10 to 10. Okay. It has started from here. This I am going to define as negative low -10, -8, -2. Similarly, this is 0 and this is positive low. And this I am going to define as 2, 8 and 10. Okay. Okay. Now, here ये params के सामने मैं लिख रही हूँ. The indices, देखो, I again explain to you. See, अच्छा हो गया आपने पूछा है. See, अभी now speed का मैं आपको बताती हूँ. Speed, now I am going to first give the range over there, -1 to 1. Okay, click on this first membership function. Right here, ये जो जगह मिल रहा है ना यहाँ पे, I am writing negative low. Come here. Here I am going to give the values of the three indices. अभी इधर -1 है ना, -1, -0.75, -0.2. These three indices I am going to write here. देखो आप. -1.0, -0.75 and -0.2. When I write that and click on to here, आप देखो इसमें जब मैं क्लिक करती हूँ, it is negative low इधर आ गया है, -1 पे एक इंडेक्स है, -0.75 पे दूसरा इंडेक्स है, -2 पे तीसरा इंडेक्स है. ये मैं इधर ऑलरेडी इट वाज देयर, उसमें मैंने करेक्शंस कर दिया. एक मैट्रिक्स की फॉर्म में मैंने -1, -0.75 एंड -2 ये पैरम जो लिखा है ना यहाँ पे, पैरम जो लिखा है उसका इधर पैरामीटर्स है, वैल्यूज दे दिया उधर. सिमिलरली हियर ऑल्सो ये MF2 जो लिखा हुआ है, MF2 को मैं चेंज करके 0 एंड उसका नीचे इधर लिखे आ रहे हैं -0.8, 0.8. I'm not changing it. You can change it or don't change it. मैंने for to save time I'm not changing it. Now here I am writing, going to write positive low. देखो to save time I am doing it same values. You can change. You change the terms. You change the values. Okay. Here it is point. Okay. Now see, again I'll show you what I have done. For angle, I have defined these three membership functions. Okay, I have defined each of it. मैं name change किया, params change किया. ये टाइप में ये ट्रायंगुलर मेंबरशिप फंक्शन है. ये एरो में क्लिक करने से आपको बहुत सारे मेंबरशिप फंक्शंस की शेप्स आता है, ट्रेपेजॉइडल, गॉसियन and all. You can choose that also. I am not changing it much. I am leaving all this for you. Angular velocity also define each one of them, and speed also you define. Now we have to falsification हो गया. Now we have to write the rules. Okay, come to view, edit में ही edit rules. One more thing. See, I have shown you 5 membership functions: negative, high, negative, low, zero, positive, low, positive, high. मैंने तो इधर 3 ही आया था, मैं 3 किया, 5 कैसे करूंगी मैं? If you wanted to do 5, how will you do? एडिट में एक add mfs करके एक ऑप्शन है, देखो. Here you can write number of mfs 3. Okay, so you change it to 5 or 4 or 7. Add mfs. तो मैं 3 डालने से 3 ऐड हो जाएगा. अभी 3 ऑलरेडी है, 3 और ऐड हो जाएगा. मेरे को 2 करना है तो 2 करो. 1 कर add mfs है. It will add the number of mfs. Okay, I am not doing it. So you can add any number of mfs. Now we have to write the rules. Edit rules. Okay, now another window is opened. एक first window था FIS editor, then membership function editor. This is known as rule editor. Now here you can see here what I have done. See, it comes if angle is and angular velocity is, you cannot see, I am reading it, then speed is. And जो मैंने negative low, zero, positive low लिखा है वो सारे इधर आ गया. Now I only have to choose. If angle is negative low and angular velocity is negative low, then speed is negative low. ये अभी selected. Add rule. First rule ऊपर आ गया. Similarly, if angle is negative low, angular velocity is 0, speed is negative low. Add rule. If angle is negative low, positive low, 0. Okay, 0. If angle is 0, negative low, add rule. 0, 0, add rule. 0, positive low, add rule. देखा आपने? If it is positive low, negative low, 0, add rule. Positive low, 0, positive low, add rule. Positive low, add rule. I have made 9 rules. You can also make. Rule बनाना इतना कुछ you only, मैंने आप लोगों को थोड़ा सा बोर हो गया होगा, फिर भी एक्सप्लेन करते करते मैंने सारे मेंबरशिप फंक्शंस एक्सप्लेन किया, सारे मेंबरशिप फंक्शंस की टर्म्स, लिंग्विस्टिक टर्म्स एक्सप्लेन किया, मेंबरशिप फंक्शन हमने एडिट किया. नाउ इट इज द रूल एडिटर. फिर रूल भी मैंने 9 रूल्स एडिट किया. यू कैन मेक एनी नंबर ऑफ रूल्स, बट व्हेन देयर आर ओनली 3 मेंबरशिप फंक्शंस यू विल ओनली बी मेक 9 रूल्स. इट इज ट्रू. 3 स्क्वायर 9 रूल आएगा. सो नंबर ऑफ मेंबरशिप फंक्शंस बढ़ाने से उतना ही रूल्स आपको बना सकते हैं. ओके, नाउ लेट अस गो टू व्यू रूल्स. दिस इज वेयर वी defalsify rules. This is the window where we defalsify. Now here we are going to evaluate the rule. जो rule evaluation मैंने आपको बोला है, that we are going to see here. See, this is the angle portion. The 3 angular positive low, 0, negative low, and the 9 rules it comes. If angle is positive low, negative low, angular velocity is negative low, then speed is negative low. जो मैंने अभी रूल बनाया वो सारे पिक्टोरियल फॉर्म में अभी इधर आ गया. Now for defalsification, the main thing is that we should have a crisp value. So there is a value here and a red line here. Hold on to the red line and move it. Similarly, according to your value. Now, depending on the crisp value of the angle and the angular velocity, the number of rules evaluated or fired will change. अभी आपको इधर देख सकते हैं, I have taken two values, angle का -1.81 and angular velocity का -3.37 value मैंने इधर लिया हुआ है. You can see that 1, 2, 3, 4 rules are now firing or evaluated. This yes, देखो आप नीचे देखो ना, आप नीचे का फिगर देखो, सबसे नीचे का फिगर, this is the combination of these four and the red line is the centroid and the value corresponding to the centroid is given here. Yes, yes. So now here as I move, because if you want to get the different speed values for an array of angle and angular velocity values, move it by your hand, mouse से ऐसे पकड़ के आप move करो, or you write here, input में आप लिखो उसको. अभी देखो आपको 3.9 लिखना है, आप कितने भी इसको मूव करो, 3.93, 3.89, उसमें आप मूव करते जाएंगे. राइट हियर नीचे 3.9 and 3.3 and you will get the output. अब यहाँ मूव हो जाएगा. नहीं, ओवरलैप रीजन में मैक्सिमम कॉम्पोजिशन जो भी मैंने अभी आपको एक्सप्लेन किया, मैक्सिमम कॉम्पोजिशन, सेंड्रॉइड मेथड, सब कुछ करके आपको आउटपुट दे देगा. यही मैं आपको, इसलिए मैंने आपको सारे मैथमेटिक्स नहीं बताया, बिकॉज मैटलैब में आपको कोई मैथमेटिक्स सीखने की जरूरत नहीं है. जैसे मैंने कल बोला है, मल्टीप्लिकेशन टेबल्स एक टाइम पे पढ़ाया है, फिर नहीं पढ़ाएंगे. तब भी सिमिलरली मैथ एमटेक स्टूडेंट्स को पढ़ाऊंगी, आपको नहीं पढ़ाऊंगी एक घंटे में. ठीक है, ओके. सो this will give you the defalsification, rule evaluation, defalsification and the crisp output value. Now tomorrow what Shimi will do it. See, we have in Simulink, see we have a system now. In that system if you want to use a fussy control, ये तो अच्छा हो गया, मैंने इसमें इनपुट लगा दिया, आउटपुट लगा दिया, वैल्यू देखा तो क्या हो गया. ये वैल्यू से मैं क्या करूंगी, मुझे क्या पता है इसका आउटपुट वो सिस्टम पे क्या हो जाएगा. सो नाउ यूजिंग Simulink you will define a control system. You will define a control system, temperature control or whatever it is. Now what you do is you have fussy control blocks. Fussy control blocks in Simulink. You keep the fussy control block in the Simulink and from there you do all these rule evaluation, rule editing, membership function, everything on the fussy inference system editor. Okay, and when the Simulink runs, it will take the system values as the input, actual system values as the input, fussify it, find the fussy output, crisp output, and bring it back to the Simulink and apply it to the output where you have to apply and get the results. आप उधर एक ग्राफ रखो तो ग्राफ में वो वैल्यू आ जाएगा. Similarly न्यूरल नेटवर्क also, जो मैंने कल आपको GUI बनाने को सिखाया, same thing you can make as a where the changes which you do in the fussy controller will be actually taken to the output interface, hardware, where you want to really control it. So the next 2 days you will be learning that. So for that only these basics of and the फसी इंफरेंस सिस्टम बनाने का क्लास आज लिया है ताकि कल आपको ये नहीं समझ में आ गया वो क्या कर रही है, ठीक है। तो इसका एप्लीकेशन हम कल देखेंगे या कल या परसों जैसे वो प्लान किया हुआ है, so that you will be able to see the actual practical applications of these FIS where we are going to use. So I think मैंने एक राजधानी जैसे बहुत एक लाइन में बनाया बोल दिया है. Now you can have a time of question and answer sessions from the nodal centers. Also you can have if you have any questions you can ask me, so that it will be very clear for you the concept of fuzzy when you go for the classes tomorrow. Max product, okay. See, all those will come.
हाँ कल दे हाँ हाँ बिल्कुल सर, वही वही वही
किसी ने क्वेश्चन पूछे?
हाँ कोई बात हाँ बस कर रहे हैं, सबमिट किया रहा हूँ। अब इसको क्या निकालने की चार्जिंग नहीं।
Prod also for the AND method or any custom equation which is done on the first as the options where you want to do it. तो आपको max min मतलब it is and or. तो or में आप max करके min में आप prod करने से आपको max prod आ जाएगा, max prod आ जाएगा. जो it depends on how you want it, you can put it like this. Okay. Any questions from the nodal centers? You can switch on your mic and ask questions.
Good evening, ma'am, from RTU Kota.
Which college?
RTU Kota, madam, Lalwani.
Yes. पूछो.
बस मैडम बहुत अच्छा सेशन था मैडम, बच्चे सब खुश रहे मैडम.
Okay, thank you. Who is speaking?
मैडम डॉक्टर महेंद्र लालवानी.
Okay, nice. I know you. ठीक है, बोलो.
बस मैडम बस थैंक यू करने के लिए फोन किया था.
Okay, thank you very much. Welcome.
Tomorrow 9 o'clock ना मैम?
10 o'clock. 9:30.
Okay, thank
you.
We
will connect you at 9 o'clock. Connection procedure will start at 9 o'clock. The class will start at 10.
Okay, thank you, ma'am. Thank you, ma'am.
Welcome.
Okay, thank you.
Anyone else from any other centers?
Good evening, ma'am. Akhilesh speaking from Mulana.
Okay, Akhilesh. Bolo.
Thank you very much, ma'am. Thank you very much. It's very nice.
Okay, nice. Okay, thank you very much.
Good day. Good day.
You are also my student. Thank you. Thank you very much. Anyone else? Dekho, I'm telling you here in this FIS editor, it is Mamdani only. It is Mamdani only. See, if you want to use other models, there is a model called Sujeno. Sujeno also. Yes. When it comes to Sujeno, I think you have to go for these custom representations. And do it. This FIS editor में हम Mamdani ही use होता है. Okay, it is having this only. See, output देखो, if वो नहीं आएगी types, so that option we have only in neural network. नहीं आएगी तो training करने का. Okay. Listen. That's a very good question. In fussy we make the rule in such a way that we get the output. Now your condition is output aaya hi nahi. Then rule change kiya, so many things are there. That is the reason why nowadays the neuro fussy approach has come. In neuro fussy approach, what happens? Now you have ANFIS. I think she may have some time, so she will speak about ANFIS also. In ANFIS, you have a combination of neural network and fussy logic, where you can train it by having an iterative approach. So it is, मैंने आपको न्यूरल नेटवर्क भी सिखाया, मैंने आपको फसी भी सिखाया, आज वो सर ने आपको GA भी सिखाया, PSO भी सिखाया. Now there are hybrid approaches of this. आजकल कोई ये सिंगल में काम नहीं करता, इसमें आपको बहुत means I will say these are very obsolete areas now. People work on hybrid areas now because that only will give you results which are required for your particular applications. So you may have to combine neuro with fussy with GA, neuro GA or neuro PSO. So combinations का आप पेपर देखो, बहुत आपको combinations का पेपर मिलता है. तो फसी का मैंने आपको बड़ा मैजिक दिखाया, वो बहुत अच्छा है. It may not be बहुत अच्छा with your particular research area which you are doing. समझ में आ गया? There you may have to go for various hybrid approaches. Nowadays the hybrid approaches goes. Okay, it is true. Your question is a very valid question. Output नहीं आया, so then you have to go for, जैसे उन्होंने बोला है membership function change करो, ये change करो. Those are all very vague corrections you can do. So then you can go for some other optimizing approaches. It is there. Okay. Any other questions? Okay, thank you very much. Thank you to all the participants at the nodal centers also. Thank you. We can conclude the class sessions now. Thank you.